Hello, everyone. Thank you for joining in. This is Faisal. Let's go ahead and get started with the session, guys. This is going to be a masterclass session on VPC, which means we are going to cover as much as possible about VPC. We'll go back to the basics as well as cover some advanced topics on VPC. However, I have to remind you that VPC is a very vast topic, which means we actually cannot cover it in a single setting here. So I've split this up into two parts. So what we will be doing today is part one, which should mostly cover almost everything to do with VPC. The part two is actually more about external connectivity that comes into the VPC. All right. All right, guys, so let's get started and let me give you a quick introduction about myself. My name is Faisal Khan. I am the founder and CEO of a company called Ecom India Cloud IT, or EICIT for short. Um, so, what we do as a company is we are a born in the cloud company and we are a managed cloud solutions provider, which means we actually help customers migrate onto the AWS platform, which includes architecting solutions for them, doing a little bit of development, then doing the actual migration and implementation. And post that, we actually help with the monitoring aspect of things as well. So it's an end-to-end solution provider that we have. We have different additional solutions that we have on our end ourselves. Like we have an e-commerce solution as well, where you can just put up your own e-commerce website directly uh, on our platform. We also have a few other hosting solutions and domain solutions as well, which are independent from AWS. Personally, I come with about 13 plus years of experience in IT infrastructure management. And as most of you already know, if you've dealt with the AWS cloud, you know that it's almost always about infrastructure management. So this is a word that you will hear quite often with AWS, which is infrastructure management, because AWS is all about implementing existing solutions or implementing existing resources in a different way, right? So it's not a completely new technology per se. All right. Apart from this, guys, I do training as well, as you might already be aware by now. Mostly, my training is concentrated around the Solutions Architect course, which is kind of a 15-day course that I cover, which is going in depth into the Solutions Architect side of AWS. So, if you are ever interested in taking a course, please free to have a look at our website, our training website. Okay. Having said that, let me give you our agenda for today. So, we're going to take a quick look at how things were before VPC actually came into being, or what was the need for VPC. What does it solve? What are the new things that it brings into AWS? Then we'll look at all the actual VPC concepts. We look at how what is VPC and what are the different components that VPC actually has. We'll look at how the architecture for VPC is done, as in how you're supposed to build a VPC. Post that, we'll actually go back a little bit into networking basics, right? So we'll look at how IP addressing is done, especially how IP addressing is done within the VPC. We'll look at things like CIDR blocks. We'll look at private, public IP addressing, subnets, and all of that. Then we'll move on to the routing aspect within VPC. So we'll see how traffic is actually routed within the VPC. And then we'll look at a new functionality of VPC, which is actually VPC endpoints. Post this, we'll actually go ahead and do a little bit of labs, which means we'll go ahead and set up a VPC, we'll configure it, and we'll do a little bit of testing with our EC2 instances as well. Post that lab session, we will take a look at the different security aspects of VPC, as in, what are the different options you have in terms of securing your VPC, and also, how do you log traffic that's flowing through your VPC. The next two topics, which is VPN connectivity and direct connect, this is actually two very extensive topics. These two topics I intend to cover in much more detail in the part two of our part two of our webinar, which is probably another day. But I will touch on these two topics in order to understand, what this is and how do you make use of it and how it helps you, right? But obviously, we'll go into much more detail, in depth on these two solutions, which is a VPN connectivity and direct connect, in our part two of our agenda, in our part two of our webinar. All right. Having said that, let us take a look at what are the prerequisites. Okay, I assume that you have knowledge of the AWS global infrastructure, because I'm not going to go back and kind of cover what regions are, what availability zones are, etc. I also expect you to have a little bit of a basic understanding of networks, which means like what is a router, what is a router, what are IP addresses, etc. Right? Also, I hope that you know how EC2 instances work, because we'll be using a couple of EC2s. So I'm not going to show you, what certain commands are within the EC2 and all of that, but I'll just run them and show you how it's done. Okay. Any questions, guys, before we proceed for the session? Are we good so far? I do want to say that because this is a streaming session, there is going to be a slight delay of maybe about 5 to 10 seconds, guys. So sometimes I'm finishing my sentence 10 seconds ago and you're hearing it a little bit later. So there is going to be a little bit of delay. So if you ask any questions, please bear with me while that question is going to take a few seconds to come up for me to see it. All right, guys. So let's move on and let's first take a look at. Okay, let's talk about how life was before VPC. So, before VPC, let's assume that this is the AWS cloud, right? So, what you used to do is the AWS cloud, before the concept of VPC came in, it was a flat network, which means this whole thing was kind of like a single network, which was shared with everyone else. So, you didn't kind of have your own network. You were just using the same network that literally everyone else was using, although you did get different IP addresses and things like that. So let's say you started an EC2 here somewhere in the cloud, then you went ahead and started another EC2 here, then you started another instance somewhere else, then another one for your DB or whatever, right? Now the thing is that if you kind of try to visualize this, um, you'll figure out that these are basically disjoint systems, which means these systems are not kind of in a single network that you own and you control. They're just part of a larger shared network, which means it's open to other issues that open networks have, which means if anyone else gets access to any part of that network, they can easily get access. I mean, they can try to get access to your VPCs because this is not a dedicated network. And these are all disjoint systems. And if you had to communicate between these systems, it was all like external communication, so to speak, because it was not within your own network. So what that means is that if anybody else also started another EC2 and then they started another EC2 as well, you see that your systems are in the same network as the other systems, right? So this was kind of a network security wise, a network issue. I mean, not much. I mean, it was secure, but it's not really something that you should be comfortable with, right? Because it's a flat network that anybody else can directly launch uh, EC2 instances into, right? And when you had to control the access to these EC2 instances, what you had was you had individual access controls. So if you wanted to protect this first system against, if you wanted to block port 80 and if you wanted to block other access, you had to do it on this system itself. And then you had to repeat that on the other system. then on the other system, then on the other. Like it was kind of a management nightmare because these were all individually separate systems, disjoint. You had to individually manage these systems because they were not part of a core network. And when you were going to try to access these systems, you had to kind of access them directly with their public IP addresses. And you couldn't actually access the network. And then from the network, you couldn't go into the systems. That was not possible because each of these systems were individual entities and each of them had a public IP and a private IP address. So you had to kind of get onto each EC2 instance. Now, this is where VPC comes in, because what VPC does for you is it kind of allocates a part of the cloud as your own network. So if you think about it, you can think about it like this, where I take off this chunk and I call this my network, right? So now this is my VPC, right? It's obviously not like, don't visualize it like this, but the idea is that now you have your own network and you can control the IP addressing in this network. You can control who has access to this network. And in fact, now what you can do is when you're trying to connect into this network, you can connect to the network and then literally you can go into all of the systems individually. You don't have to like go into the systems individually directly, but rather you connect to the network and then you can communicate with private IP addresses to all of these systems. So this is the idea of VPC. Now let's take a closer look at what are the different functions or features that VPC brings in. So VPC is essentially short for virtual private cloud. It kind of creates your own network within the AWS network. So instead of having a flat network where everyone else is starting EC2 instances on the same network, now you get your own little network within which you can actually control. So you kind of get your own network and you can kind of have your own IP addressing on that. We will cover these IP addressing in a little bit more detail later on. So let's say you have your own network and then you can have your own systems in that network and you control this network, right? You are the administrator for this network. No one else has access to it unless you decide to give them access to it. And all of these systems can communicate internally with their private IP addresses. You can connect to this network to communicate with the private IP addresses of the instances, etc. Right? So you basically get your own chunk of the network. Now, the key point to remember here is that this is a virtual network, right? So it is not a network where you're getting a physical part of the AWS network. You don't get that, right? You don't get a physical network with an AWS. It's more or less a virtualized network on top of the physical layer. What this means is that there's two options here, even under virtual, which is you can take something called a dedicated tenancy as well. You can let AWS handle this virtual network, which means they will use their networks to they will use their network routers to create a virtual LAN, so to speak, for you. So those of you in the Cisco world and things like that, you might have heard about the term VLAN. So that's kind of what it is, right? You get your own VLAN. However, you can tell AWS to actually give you dedicated hardware that manages your network. So instead of using routers or routers that are actually managing multiple networks, you can ask AWS to give you your own router, which is a dedicated hardware, which controls your VPC. All right. Again, this does not mean that you're actually getting a physical network. You're basically getting devices that are dedicated to you that control your VPC instead of having devices that are shared that are still giving you the VPC. I don't want you to confuse this at the moment. This is something called dedicated tenancy, which not a lot of people use in general, unless you're, of course, a corporate who's actually trying to secure your network take your network to the next level and secure it from external hardware. So virtual private cloud is basically having your own defined network within AWS. It allows you complete control of your networking environment, which, like I mentioned, you control the access as to who gets into your network, what kind of traffic goes out from your network, etc. There is something called the VPN and Direct Connect, which I kind of touched on the agenda. You can connect to your network to the VPC from your existing network. For example, let's say you have your existing data center, right? This might be your data center, this might be a corporate office, this might be anything outside of AWS, okay? And then you have the AWS cloud, and then you have your VPC in the AWS cloud, and obviously you have your systems inside your VPC. Now, using VPN or Direct Connect, what it allows you to do is it allows you to connect your existing router or your existing router in your data center. It allows you to make a direct connection into the VPC. Okay. Now, when you do that, when you make that connection, essentially what happens is this whole thing that is your VPC plus your data center becomes a single network virtually, okay, not physically. It virtually becomes a single network. And then what you can do is you can communicate with your systems from the data center into your systems in the VPC using private IP addresses. Okay, you don't need to go out to the internet in order to communicate with your systems. You don't need to use the public IPs. You can just use the private IPs and get connected to those systems, right? We will talk about this in a little bit more detail as to how you can connect all of these things together. But this is something that VPC allows you to do, which means it allows you to make a direct connection from your existing data center. It allows you to make a VPN or a direct connect into your VPC, and then your internal systems in your data center can communicate with your systems inside your VPC using private IP addresses, which means you don't need to expose your network into the public network. If you have multiple VPCs, you have a VPC one here, and then you have another VPC somewhere else, you can actually connect these two VPCs together, and systems inside these VPCs now can talk to each other by enabling something called VPC peering, right? We will again discuss this in a bit more detail. It allows basically you to connect multiple VPCs together and transmit traffic between them without having to go out over the internet. Till about a few months ago, in fact, till before, I think sometime before October of last year, um, there was only VPC peering that was allowed within a single region. But since then, they have released a VPC peering across regions, which means if you have a VPC, let's say in the Indian data center in Mumbai, and you have another VPC in the US East zone, you can basically connect both of those VPCs together with VPC peering without having to worry about different options like VPN or Direct Connect or any of the other things. You can directly connect both the VPCs together and have them talking to each other. We'll try and demonstrate this in our lab session today. Okay. Now, I'm going to help you visualize this to understand this a little bit better so that you can figure out how these things work together. Now, I want you to visualize this as the entire AWS cloud. Okay. I know it looks better than this, but this is the best I could do, so please bear with me. Okay, so this is the AWS cloud platform, and on top of this, or inside this cloud, you're basically going to build your VPC. So this is your blue layer, which is your VPC. This is the chunk of the network that you have subscribed for yourself. So no one else can take this network. This network is yours. Now, what you have to do is you have to split your network into smaller chunks, because sometimes managing a large network like a /16 has a lot of IP addresses, to be precise, more than 65,000 IP addresses. So sometimes managing those many IP addresses is not a good idea. So what you would do is you would actually split them into smaller chunks known as subnets. All right. Basically, they are sub networks of your main network being your VPC. So think of these green boxes or these green platforms as your subnets. So you have your VPC here, and then you have these green platforms, which are your subnets. Okay, so you create your subnets in your VPC. Will obviously discuss what a subnet is and how you create that and all of that in the coming slides, but just try to visualize this for now. What you would then do is you would actually put your different EC2 instances depending on your application, right? So in one subnet, you might put all of your databases together, right? There might be another subnet which inside which you put all of your application servers together, right? Then there might be another subnet which you put all of your web servers together. So the idea is when you break up subnets into smaller chunks of the network, you can put similar systems that perform the similar function under the same subnet, right? Because we will see later on as to how you can control the access to these subnets. So the access that this subnet has might be different from the access that this subnet has because you're going to specify certain rules. So what you can do with subnets is once you split it up and make into smaller chunks, you can give different subnets different access levels. So what you can do is for your database subnet, you can completely prevent external access to your database subnet, which means no one from outside your VPC can connect to your databases except for the systems in your VPC. However, for your web servers, you have to allow external access because those are web servers. They're web facing servers, right? So in this way, you can actually control your different subnets inside AWS. Now, you obviously have a router or a router that sits within your VPC that does all the traffic routing between all of your different subnets. Now, let's say you actually have your office network, right? This is your data center or your office network. And you have your own little router or your gateway in your office. Now, we talked about connecting the data center or your office with the VPC, right? In order to do that, you have to introduce something called a virtual private gateway, right? A virtual private gateway. What this virtual private gateway allows you to do is it allows you to connect your existing on-premises data centers or your existing networks inside your corporate office. It allows you to make a connection into your VPC. Now, when you do that, like I told you before, the whole thing basically becomes a single network, a single private network. So now it's as if the VPC and your data center and your office or your corporate office is in the same network. Now you can talk to the other network just like as if it was the same private network, because now both of them are connected together using something called a virtual private gateway, which allows you to connect both of these networks together. Now, having said that, remember I told you if you have your server inside your existing office network here and you want to communicate with your database servers, remember I told you that you might want to configure this subnet in a way where you do not want to allow external access to your databases, right? So anybody trying to come into the databases from outside your network will be denied access. However, because your corporate data center is now connected to your VPC using the connection here, either using a VPN or a direct connect. Now you can talk to the virtual private gateway, which then talks to the database layer. So now you can connect your databases from within your office, and your databases are not accessible to anyone outside the world, outside the VPC. However, you can still open up certain subnets to the outside world. So we talked about our web server subnet, right? Now I can still allow external access to my web server subnet. So anybody coming from the internet can still access my web servers because I have allowed the access to happen. Now we'll definitely see how that works. We'll talk about route tables and subnet access and all of that. So I hope you have got a better visualization of how these things happen on AWS. I'll pause here for a moment and I'll ask if you have any questions before we go ahead and proceed with the rest of the session. So the question is, can I connect multiple corporate offices to the same virtual private gateway? Yes, you can. However, remember that the virtual private gateway has a limitation of 1.25 gigabits per second bandwidth. So you might run into problems if you have multiple networks connecting into that and your bandwidth exceeding that, right? However, you can definitely do that. All right, I will wait for another 15 seconds to know if you have any other questions. All right, I hope you guys are able to follow what I'm saying here. Okay, there's a question. I assume you'll explain VPN and Direct Connect. We will be touching on VPN and Direct Connect towards the end of the session, and I will be explaining all the parameters and requirements, but not in depth because, like I mentioned, that in depth is going to be in the part 2, right? Okay, Raj has a question. What exactly 10.00/16? So don't worry, Raj. We are going to cover that in much more detail when we actually go into the IP addressing part, so that you know how those IP addresses work in the VPC. Subnets and AZs are the same? No, Srinath, they're not the same. Subnets are just smaller chunks of your network. You can have multiple subnets in the same availability zone or AZ. You can just use one AZ for all your subnets, or you can use multiple AZs for all your subnets. It doesn't really matter, but they're not the same thing. We will see that in the next slide when we look at the architecture. All right. So I'm going to go forward, and this is how the architecture looks, guys. So this image, I want you to kind of burn this image into your memory, because if you're ever going to be dealing with VPC, this is kind of the first thing that you have to do in terms of architecting, which means you have to kind of draw the diagram and how everything fits together. Now, let me explain this to you. So in the outer layer, you have AWS. Within AWS, you have different regions, right? So you have the Mumbai region, you have the US East region, you have the US West region, several other regions that are there. Whichever region you're creating your VPC in, you will have, just one second. Okay, so you have your region, and within your region, you have all your availability zones, right? I am taking an example of a region with 3 availability zones. It's not that each region will have only 3. There are some regions which have 6 availability zones, some which have 5, some which have 3, but the minimum is 2. In a region, there will always be at least 2 availability zones. Okay. So you have your availability zones, and then within your availability zones, you will actually create your VPC. Now, when you create your VPC, you're creating your VPC in the region. You can't create it within a particular availability zone. When you create a VPC, it stretches across all your availability zones. All right. And within your availability zones is where you go ahead and create your subnets. Now, it's not necessary that you have to use all your availability zones. You can just use 2. So let's take an example where you have the AC1Z, 1C, and you might not have any of these subnets. This might just be blank. That's perfectly fine, right? It's not necessary that you have to kind of have a subnets in all of your availability zones. That's not necessary. So you have your VPC, which stretches across all the availability zones. But remember, a VPC is always within a region. It does not stretch across a region, right? If you want VPCs to connect together within different regions, you use VPC peering, where you have a VPC in one region, you have a VPC in another region, and then you connect them together using VPC peering. But we'll discuss that later. So you have your availability zones and you have your subnets that are there. Now, don't worry about what public and private subnet is. We'll go into detail of what that is. But you need to create public and private in order for you to define what your applications are. Remember, I showed you the slide before where I told you that you might want to put your databases in a subnet which does not have internet access, right? That's where you would put your databases. So you would put your databases in your private subnet, all right? Or any servers that do not need access to the internet, all right? Or should not be allowed access from the internet, you put them in something called a private subnet. And obviously, all your web servers and everything, you will want to put it in your public subnets. Now, remember, when you create a subnet, there's nothing called a public or a private subnet. When you create a subnet, you just create a subnet, right? It's later on when you start defining rules for your subnet that that subnet either becomes a private or a public subnet. And when you make a subnet public, you can later on change that and make it private. Or if you already have a private subnet, you can change the routing information and make it public. So the thing called private and public subnets, they're not static, guys. And it's not something that you create as a private or you create as a public. You first create a subnet, and then later on, when you go change the routing information, you decide whether you make that subnet public or whether you make that subnet private, right? We will definitely see how we make that. All right, don't worry about that. I think there is a question here. Okay, I'll touch on that question later. Okay, so this is kind of the architecture, right? You will have your availability zones, and your VPC will be stretching across all of those availability zones, and you will have different subnets in all of these availability zones inside which you will place your systems. Now let's go ahead and have a look at all the different components of a VPC. Now, I will come back and touch again on the subnets. I've kind of talked about it a little bit now. We will come back again and look at how you create subnets, how you define the different IPs for your subnets, and all of that. We'll touch on that a little bit later on. What I want to go now to is route tables and router. Now, these two things are interconnected. The router works by looking up information in the route table. Now, for those of you who worked in networking, you kind of already know what a route table is. But for the others, a route table basically holds information about where something should be sent, right? So when some communication happens, let's say from IP address 10.0.0.1 or 0.10, and then that goes to IP address 10.2.0.5, this information as to how this IP is supposed to communicate with this IP, that information will be found on the route table. If there is no route that specifies how does this IP go from this place to this place, if there is no route specified in the route table, then that communication won't work. This first system won't be able to reach the second system. Let me just demonstrate that a little bit better. So you have two systems, and the IP address of this one is 10.0.0.5, and the IP address for this is 10.0.0.6, right? There should be some information in the route table which says how can 5 communicate with 6, or which route does 5 take to communicate with 6. If that information is not there, this system cannot communicate with this system. All right. So when this system 10.0.0.5 makes a request to 10.0.0.6, that information gets sent to the router. The router goes ahead and looks up the route table and asks the route table, how do I go to that system? How do I go from 10.0.0.5 to 10.0.0.6? If the information is there, then the router will go ahead and route the packets accordingly. If that information is not there, obviously that communication is not going to happen. It's going to be either something like a request timed out, right? And these are two basic components, and we'll deal with more with route tables when we start looking at how to create public and private subnets. All right. So a route table holds information about how the routing happens, and it's a router that routes based on that information in the route table. All right. Now, do understand that almost everything that you're seeing here, almost everything is virtual devices, right? None of these are actual physical devices. They're all virtual devices that are built on top of physical machines, right? So it's not like a physical router that you're getting. It's a virtual router that's there in your VPC. Okay, so what's an elastic IP? An elastic IP is basically a static public IP. Now, when VPC came in, whenever you started a VPC in the, whenever you started an EC2 in the default VPC, by default, dynamically, an IP address is assigned to your EC2. Okay. Dynamically, an IP address is assigned to your EC2 when you start up a new EC2 in your VPC. However, that dynamic IP is not permanent, which means if you stop your system and start it, that IP might change, right? So rather than relying on dynamic IPs, you can assign something called an elastic IP to your EC2 instance. When you do that, your IP is permanent till you release that IP. So you might want to have a public IP, something like 56.15.20.9. Of course, you don't get to pick and choose, but you will randomly get an IP address. That IP address will be assigned to your elastic IP. I'm sorry, that IP will be assigned to your system. So that's basically what an elastic IP is. It's nothing but a static public IP address. Having said that, the elastic IP and the ENI, or the elastic network interface, work together. The elastic network interface, it's I just want you to simply think of it as a network card. It's basically a virtual network card. It's kind of a network port for your EC2 instance. So if you need network connection for your EC2, you have to have like a network card, and that network card is nothing but the elastic network interface. The thing is, whenever you are assigning IPs to your EC2 instances, whether it's an elastic IP or a dynamic IP, those IPs always get assigned to the interface and not to the actual EC2, right? So it does not get assigned to a particular EC2 instance as such, but it gets assigned to the interface. Then this interface gets assigned to your EC2 instance. What that means is, if you have, let's say, 2 or 3 network interfaces, okay, and okay, let me kind of map this out. Let's say you have an EC2 that has 2 network interfaces, 2 elastic network interfaces. Both of them have an elastic IP associated with the network interface, right? So there is an elastic IP attached to this, and there is an elastic IP attached to this network interface. So essentially, your EC2 has 2 public IP addresses that are static. Now, let's say something happened to this server, it went down, and that you're not able to fix it immediately. You can fix it, but it's going to take time, and you only have one server, or you did something like that. Then you can easily go ahead and start up another server, disconnect these network interfaces from this, and reattach it to this system. And you can continue using your existing IPs without having to change any other IP routing, which means you don't have to go to DNS and change IPs or anything. You can just reattach the network interfaces from one system to the other, and then you can continue using your existing IPs. It's as if nothing happened, right? So you don't have to use new IPs for your new system. You can continue using your existing IPs, right? So this is what the elastic network interface allows you to do. The internet gateway, it's as simple as it says. It's a gateway that allows you to connect to the internet, right? Now, if I were to just go back here, let's say you had an EC2 instance in your public subnet, which is your web server. Now, if this web server needs to talk to the internet, or if it needs to allow internet access, there should be an internet gateway that is configured in your VPC, so that when traffic comes in, it comes in through your internet gateway and then goes to your VPC. Same way, when traffic goes out, it goes out to the internet gateway and then goes out to the internet, right? An internet gateway is nothing but like a door at your VPC that allows external communication to happen, whether it is inbound external communication or outbound external communication, right? So an internet gateway is as simple as that. It just allows you to communicate between external and internal VPC. Okay, I'll pause here for a second and ask any questions regarding these components that we have covered so far. There's a question from Gaurav. Can I create multiple VPCs in the same region? Yes, you can create multiple VPCs in the same region. Is subnet auto created when we create EC2 instance, or is it separate from the instance? Raj, it is separate from the instance. It's not auto created. You basically have to have a subnet in order to put your EC2 in it. Your EC2 cannot just be placed randomly anywhere. Your EC2 has to be placed inside a subnet. and the subnet should already exist. Is the static routing or even dynamic routing protocols are supported too? So when we talk about VPN and direct connect, we will talk about dynamic protocols like BGP and all of that. But as of now, within our VPC, we are always going to deal with static routes. um, BGP is supported for external connectivity like VPN and direct connect. uh, Chandu has a question: with the VPC public subnets and private subnets, it will work. Within the VPC public subnets and private subnets, it will work. Chandu, I'm not sure if I understood that question. uh, can internet gateway connect with private subnet too? So we'll talk about how the systems inside the private subnet can get internet access that is not using the internet gateway, but we'll talk about something called a NAT gateway. All right. That's the last one on the table, so we'll talk about that a little bit later on. How many static IPs can be attached to ENI? Is there a limitation? So think of it like an IP goes to one IP goes to one ENI. All right. Elastic IP chargeable? Yes, Elastic IPs are chargeable. There are some free limits, guys. There is a little bit of fine print, so please look up the details. As Elastic IPs are not chargeable as long as you have connected them to a working EC2 instance. All right. That is up to, I believe that's two Elastic IPs, which are free if you have them connected to a working instance. If you just have an Elastic IP that is attached, that is in your account, but you have not attached that to any EC2, then you will be charged for that Elastic IP. Yes, I hope to put up the recording later on, so you should be able to find it. Which one has weightage, NACL or security group? So we will cover that, Balasundaram. We will cover that a little bit later on. We will talk about NACL and security group in a little more detail. Shijit, what is BGP? BGP is a dynamic routing protocol. You don't need to worry about that right now. Towards the end of the session, I'll kind of touch on that, but that's a little bit more on the advanced networking side. If you don't know that, you probably won't be using it in the VPC. Is it possible that the single ENI consists of many IPs attached to it? So I will link some documentation here as well, guys. So some of these questions are more FAQ related kind of things. Um, Single answers, not. So I will link them here. How many maximum of ENIs are supported on a single EC2? So guys, there is a section whole on the limits as to how many of this is possible, how many of that is possible, all of that. I will share that table with you so that you can have a detailed look at it, as to how many per ENI, how many per VPC, how many subnets, all of these things. There is actually a limit on them. There are soft limits. I will share that documentation with you. You select or free select an IP address. All right, guys. So I'll move forward now. So the next three components are customer gateway, VPN connection, and virtual private gateway. Now, the reason I told all of them together is because this is how you actually establish something called a VPN connection. If you need to establish a VPN connection, you need all of these three components to work together. So on your side, you will have your customer gateway, which is nothing but your router in your premises, right? And then on the AWS side, there is a virtual private gateway, which, if you remember, I kind of showed you in that representation there. You will basically use the VPN connectivity to establish a VPN connection between both of these endpoints. One endpoint is your customer gateway, which is your router in your premises, and the other one is the virtual private gateway, which is the router on the AWS side, or the gateway on the AWS side. You basically establish a IPsec VPN connection between these two endpoints. We'll touch on this a little bit more in detail when we look at the VPN section. Right. Now, I talked about VPC peering, guys. So VPC peering is nothing but when you have two VPCs together, you connect both of them. You basically have to send a request first, and then the other VPC accepts the request, and then you have the connection there. So I'll demonstrate that to you during the labs. All right, let's talk about VPC endpoints a little bit. VPC endpoints are basically basically connectivity that allows you to talk to certain AWS services privately. Now, I will be covering this in a little bit more detail just before our lab session. I have a couple of slides on that. So, what I will just tell you right now is what used to happen is when you try to communicate from your EC2 to, let's say, something like an S3 service, how it used to work is that S3 only had public endpoints, which means when you talk to S3 from your EC2, it had to go out over the internet, right? It was not a private communication. It had to go out over the internet and connect on the S3 public interface. So whatever you were transmitting between your EC2 and your S3 buckets, they were public, as in not fully open as such, but it was going over the public lines, right? Which means that's not good if you're talking about data security. What VPC endpoints allow you to do is, if you have the EC2 and you have the S3, you have the VPC endpoint. It allows your EC2 to talk to the endpoint which talks to the S3, but this is private connectivity, which means it doesn't go out through the internet. So whatever you're transferring between your EC2 and your S3 buckets, they're going to be in the private domain. They're not going to go out over the internet. Like I mentioned, I have a slide on this, which I'll cover in a little bit more detail, but just understand that this is how it works as of now. NAT gateway also is something that I'll cover a little bit more detail. But let's come back to that question about why would private subnets need access to the internet. So let's say you have your database here in your private subnet. Okay. Now, obviously, your database does not need to allow access into your database from the outside world. However, your database server is still a server and it needs updates and it needs patches, right? And the only way it can get that is by talking to the repositories that are outside on the internet. So, how do you get your internal EC2 systems that are in the private subnet? How do you get them to talk to the internet? What you do is you use something called a NAT gateway, right? So you will have a NAT gateway. Now, this has nothing to do with the network natting process, guys. It's different. What the NAT gateway allows you to do, the NAT gateway basically sits in a public subnet. So what the NAT gateway allows you to do is it allows the DB to talk to the NAT gateway, which forwards the communication then out to the internet gateway, and then it can talk to the outside world. However, the NAT gateway will not allow any new communication to be initialized directly into the database. It's not going to allow that. It'll only allow the outbound connection and the reply on the same connection, because it remembers what port it went out and it remembers that the request was actually made by the database. So it'll allow that request back in. So if the database is requesting for a patch for MySQL server, then it will let that patch come back in because that request was made from the database from the private subnet. However, it will not allow any new communication to be, or any new connections to be initialized into the database. That's what the NAT gateway does for you. We will cover, like I mentioned, I'll cover this in much more detail later on. Any questions, guys, before we proceed? Like I mentioned before, you do not have the option to select the IP addresses. They're random IP addresses that are assigned to you. Okay, I will proceed. Okay, so now let's take some time and let's go back a little bit and talk about IP addressing and subnets. Now, for those of you who are already networking ninjas and already know what subnets are and IP addressing is, this might be a little bit boring for you, but hang around, you might learn something new. Now, when we talk about IP addresses, I'm going to give you a simple IP address that we almost deal with on a daily basis. Think of your home network IP address, right? Which is something like 192.168.100.201. Now, In these IP addresses, each of these are known as octets. Okay. They are known as octets because each of them are made up of 8 bits. So, technically speaking, each IP address is made out of 4 octets of 8 bits each. Now, when we talk about bits, it's going to look something like this. So, what you have here on the screen is this 8 bits actually represent the number 192. These 8 bits actually represent the number 168. These 8 bits represent the number 100. And these 8 bits represent the number 201. Obviously, you can change the bits around to represent different numbers, but just understand that each of the IP address in an IP addressing range, it has 4 octets, and each of the octets are made out of 8 bits. Now, what that means is that when you add all of this up, 8 plus 8 plus 8 plus 8, you get 32 bits, which is why IPv4s are basically 32-bit IP addresses. Anybody know how many bits IPv6 is? Sorry, I wrote IPv6 here. It's actually IPv4, guys, is 32 bits. Anybody know how many bits IPv6 is? Quickly. Right? IPv6 is actually 128 bits. So you have a lot more IP addresses. Now, what I mean by that is this number 32 is important when you start talking about CIDR ranges and how you do IP addressing within AWS VPCs. I want you to listen carefully here because this is a part where you actually start using IP addresses inside your VPC. Now, there's something called IP CIDR range. Now, what a CIDR range is, it's basically a notation, or you write an IP address in a particular format so that when someone looks at that, they know exactly how many IPs are there in a network. They know how large the network is, and additional information about that particular network. How you would write a CIDR range is something like this. So, for example, this is a CIDR range. And as you can see here, it specifies an IP address and then it specifies a number. Now, this number has a significance to this number up here. What this number 16 specifies is that the first 2 octets of this are not going to change. Here's how it works, guys. The number here is 16. You need to start counting from the left side. All right. So we know that each octet is 8 bits. So we eliminated the first octet. So we took out 8. So how many remaining? 8 bits are remaining from the 16. So then I took out the second octet. Now I have taken out 16 bits. What this 16 is notating is that the first 16 bits of the IP address is not going to change in the IP range. Because when you write a CIDR range, you're not actually specifying a single IP, you're actually specifying a whole range of IP addresses. All right. When I say /16, the actual range is going to be something like this, which is 10.0.0.0 up to 10.0.255.255. Now, the reason it's stopping at 255 is because the largest number that you can represent with 8 bits is 255. If you need to represent the number 256, then you need 9 bits, right? So we know that each octet can only do maximum 8 bits. That is why you always have an IP address with a maximum limit of 255. Let me just revisit this here again. I wrote an IP range, which is 10.0.0.0/16. Now this 16 number signifies the number of bits that are not going to change. So I start counting. 8 bits gone, 8 more bits gone. So now I know that this much part of the network is not going to change in the range. So when I write the range, this bit will always remain the same. It is only this part and this octet and this octet that is going to change. What this means is that there could be an IP 10.0.1.5 is an IP address in this range, because think about it, the first 16 bits don't change, guys, which means we just need to make sure that this remains constant. The second and the third octet, I'm sorry, the third and the fourth octet can change. So there might be another IP like 10.0.15.9. Can you guys give me a few more IP addresses in this range? Anybody can give me a few more IP addresses in this particular CIDR range? Okay. Just repeat this part if you haven't understood this. When I say 10.0.0.0/16, I'm specifying an entire IP range, and I'm telling that the first 16 bits in that range is not going to change, which means whenever I write an IP address in this range, the first two octets will always remain the same. Okay. Which means 10.0.19.20. Remember, this third and the fourth octet can be any numbers up to 255.255. So having said that, can you guys give me another IP address in this range? Just give me another IP address in this range. Okay, Balsundar says 10.0.16.0. So you're giving me another range, but I need a single IP in this range. So let me move on here, and I will give you another example so that let me test you on that. So let me say I have an IP address range called 192.168.0.0/24. Can you guys now tell me what is the what is the IP range on this, guys? Can anyone give me the IP range on this, guys? I don't want a single IP. I want the entire range. So I'll give you another 30 seconds. Okay. Here's what it's going to look like, guys. It's going to be 192.168.0.0 up to 192.168.0.255. Remember, dot zero is also an IP address in the range, so it doesn't start from dot one. It starts from dot zero because dot zero is also an IP address part of the range. All right. I think Hemant and Srikant kind of got it as well, which means let me just clarify this for you quickly. Okay, when I say 192.168.0.0/24, I'm saying that 24 bits of this IP address is not going to change, which means 8 plus 8 plus 8. What that basically means is that in this CIDR range, the first three octets are not going to change. It is only this octet that is going to change, which means this can be anywhere from dot 0 up to dot 255, right? So if I were to write an example IP, that would be 192.168.0.10 or dot 0.15, 0.21, etc., 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 right? So I hope you guys understood what a CIDR range is. It's basically a notation where you're specifying a particular range of IP addresses. So when you create a VPC, you have to specify what is the CIDR range of that VPC. All right. You're basically telling AWS that I'm going to use X number of IP addresses to define this VPC. How large you make the VPC is actually very important, because if you look at it, if I say a slash 16, okay, that means two octets are going to change, right? The third and the fourth octet is going to change, which means it can be 256 IPs into 256 IPs. That basically translates to a total of 65,000, I think 536 IPs, if I'm not mistaken. This is the total number of IPs that you have in a slash 16 network. So when you specify the CIDR ranges for your VPC, remember your VPC is your main network. So when you specify a CIDR range, you should specify such a range that it has enough number of IP addresses so that you can assign it to all the systems, but it also should not be so small that you actually run out of IP addresses. Because let's say, for example, I created a VPC and the CIDR range that I gave it was 10.0.0.0/24. Okay. When I say slash 24, it means the first three octets are not going to change. It's only the last octet that changes, right? Basically, what I'm telling here is that there are 256 IPs in this VPC. I'm basically limiting my VPC to not more than 256 IPs. So when I create subnets, I have to kind of divide those IPs into different smaller subnets. Then it's technically speaking, I might not have more than 15 or 20 IP addresses per subnet. That's not really good. So you have to have a subnet, you have to have a VPC large enough so that you have to have a VPC large enough so that you can assign enough IP addresses to all of your subnets. Now, there's a question from Lalith about CIDR range can be changed in a VPC later on. Now, recently they introduced an option of additional CIDR ranges. Okay. What that means is, let's say you first made the mistake of doing this. You assigned a VPC CIDR range of 10.0.0.0/24. Now, what you can do is you can actually add an additional CIDR range 10.0.1.0/24 to your VPC. So now you have 256 plus 256 IPs, right? So you cannot delete or modify or change your existing CIDR range, but you can add additional CIDR ranges if you wish to. All right. But obviously, they should not be conflicting. The CIDR ranges should be different from each other. Now, having said that, let me ask you the CIDR range for 10.0.1.15/32. Can you tell me how many IP addresses are there in this and what is the range of IP addresses? Can anyone tell me that? So the IP address in question here is 10.0.1.15/32. Okay. So some of you got this right. So a /32 is basically specifying a single IP address. Now remember, almost everywhere, wherever you put in an IP address, you have to write it in the CIDR notation. So for example, let's say you basically want to allow only one IP address access to something. So when you do that, you have to specify it in the CIDR range format. You can't just put in, I only want to give access to 10.0.1.15. Rather, you should specify it in the CIDR range, because a /32 means there is only one IP in this range, and that IP is 10.0.1.15. All right. So if you want to ever represent a single IP using the CIDR notation, you will actually do the /32. Now, without complicating things too much, I just want you to understand that when you write CIDR notations, it is not necessary that it always has to be multiples of 8. Okay. It can be 21, it can be 19, it can be whatever. It necessarily does not need to be a multiple of 8. But just to simplify things a little bit, here's what I want you to understand is that when you do 10.0.0.0 slash, let's say I am doing 26. Okay. So this is my CIDR range. It's 10.0.0.0/26. Here's how it's going to work. You're going to count 8 plus 8 plus 8. So you've already counted 24. So what's remaining is 2 over here. How this basically works is the way you represent 0. Okay. Out of that, let's say, for example, there are 8 bits. Okay. Let's say 110, 010, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So these are 8 bits. What basically happens here is the first 3 octets do not change. That we already know because we have already discounted 24. Now we need to also specify that the next two bits in the last octet is not going to change. So what happens is these 2 bits are not going to change, but the remaining 6 bits will actually change in the IP address. Now, this actually requires subnet calculators to understand how this works. So I will show you a link which will actually help you get to these subnets. Just give me 1 second. So if you just go to Google and do subnet calculator, the best one that I would recommend is there's one called jodis.de/ipcalc. If you go there, and let's actually specify something that we already kind of did. So let's do 10.0.0.0/16. Okay. I do that. It shows me what is the minimum, okay, and what is the maximum. Now, don't worry about these 255s and all of that. I will talk about usable IPs and non-usable IPs. But you see, there is basically a total IPs of 65,534. Okay. Now, you see this is that these 2 octets remain the same, right? Because we are saying /16. All these bits are exactly the same. If you look, it is only in this 2 octets that it is actually changing. Now let's say I say 10.0.0.0/26, the same example that we took. So if I calculate this, you see how it splits this up. So the first, second, and the third octets does not change, because out of that /26 we have already taken out /24. So that's not going to change. But you see how it is actually separated out these 2 bits from the 8 total bits. So if you see, this is 2 bits plus 6 bits, that is forming the total of 8 bits. So it's going to be something like this. It's going to be like 10.0.0.1 up to 10.0.0.62. It's not going to go up to 255, because the maximum number that you can represent with these many bits is 62. All right. So if you're going deeper into the networking side of things and you have to do something that is not in multiples of 8, then you have your subnet calculator here. However, when you start dealing with VPCs and initially when you start working with them, you will most probably be working with something like /16, /24s, etc. Right now, one thing that you'll need to understand here is that, guys, okay, there's one thing that you need to understand here is that a slash 16 is a larger network than a slash 24. Okay, which is obviously larger than a slash 32. You have 65,536 IPs here, you have about 256 IPs here, and you have one IP here, right? So this is how your network sizing is. So remember, when you create your VPCs, it's ideally better that you create it with a slash 16 so that you later don't run into issues of not enough IP addresses. Having said that, your VPC should be a maximum of slash 16 and a minimum of slash 28. You cannot have a VPC smaller than a slash 28, which means you cannot have a slash 31 or a 32, right? Your VPC has to be in the range between slash 16 and slash 28. Having said that, when you're specifying your IP addresses in the CIDR range for your VPCs, you should actually be specifying it in the RFC 1918 standard, which means you can have a 10.0.0.0/16. Um, Remember that this is the RFC 1918 standard. So a slash 8 or a slash 12 or a slash 16 that you see here does not mean that you have to apply exactly as it is. It is just saying that this range is possible, which means if you go for a 10.0.0.0 range, it has to be anywhere between the slash 16 to a slash 28. It has to be between that. You can't go above slash 16, which means you can't go slash 15 slash 14 slash 13 etc. You can't do that. It has to be within the slash 16 to slash 28. Same way you can do a 172.16.0.0. You can also do a 192.168.0.0. Now you can bring in your own public IP addresses, which means if you want your VPC to have your public IP addresses, you can do that. However, you have to own those public IP addresses, and then you have to go through AWS in order for the routing to be configured so that your public IP addresses are assigned on your VPC. One more important thing that I have to mention here is that within a VPC, certain IP addresses are not usable, right? This applies to your subnets as well. So in your VPC, the dot zero, the dot one, the dot two, the dot three, and the dot 255 is not accessible. Regardless of whether it's a 10.0 or a 192.168 or a 172, regardless of whatever it is, the dot zero, the dot one, the dot two, the dot three, and the dot 255 is not usable. They're reserved for certain things on AWS, which means you cannot assign them to any particular EC2 instance or any service that you have. The dot zero, ideally in a network, always the dot zero and the dot 255 is generally not usable, because the dot zero is the IP of the base network and the dot 255 is the broadcast IP address. Anyways, broadcast is not supported within VPC, so you don't have these two IPs anyways. So out of 256, if you remove two, generally speaking in any network, usable is 254 IPs, right? Which is why if I go here and if I put a slash 24, the total number of hosts is 254. Although the IP address, including the 0 and 255, is actually 256, but the usable is only 254. That's almost common in all the networks. So apart from these two IP addresses, three more IP addresses are not usable within AWS VPCs, which is dot one, dot two, and dot three. As it's mentioned, dot one is reserved for the internal VPC router. Dot 2 is actually reserved for the internal DNS server that AWS provides. Dot 3 is not yet used for anything, but it is reserved for anything that AWS might come out with in the future. So I'd like to stop here for a second and ask if you have any questions. Let me also review some of the questions that are already been put there. Pranaya has, can you give an example of fully having 11 IPs? So Pranaya, please use the subnet calculator that I've mentioned. You can pick and choose over there. What exactly we provide CIDR range? Is it the time of creating? Yes. When we do the labs, I'll show you how you create the CIDR ranges. Can you please tell me how many such things are present, like /16? Right. So I kind of answered that already, right? So you can do between a /16 and a /28 for your VPC. Um, however, outside of it, literally any slash is possible, right? /28 is a minimum range subnet we can define. Yes, true. Okay, so I'm not going to go into class A, class B, and class C IP addresses. That's a complete different discussion about IP addresses. I'm keeping it very specific to IP addressing within the VPCs. All right. For that, like I mentioned, you have to use the RFC 1918 standard for the private IP addresses. All right, you're welcome, Raj. What is the default VPC range in AWS? So we'll take a look at the default VPCs and all of that. When you create a VPC, there is nothing like it will by default give you a range. You have to specify the range for the VPC. All right. However, there is a default VPC available in every single region. This was created so that people who were using the classic EC2, which is before VPC, I forgot to mention that was called classic EC2, which is before the VPC came in. That's what it was called. So people who wanted to migrate classic EC2 into the VPC, AWS actually created a default VPC within every single region. So if you go into your AWS dashboard and have a look at the VPCs, you will always see at least one default VPC in each and every region, right? Okay, so I'm going to proceed now. Okay, let's talk a little bit about subnetting here. Okay, so let's say I have my VPC and my VPC's IP addressing CIDR range is 10.0.0.0/16, which means literally 65,536 IPs are possible. But I definitely want to break it up into smaller chunks or subnets. Now, I will have the different availability zones. And in this example, I'm taking a VPC which has two availability zones in it. And what I will do is I will create subnets within both the availability zones. Now, when I create the subnet, guys, there's one important thing here to understand is that when you create the subnets are sub networks of your main VPC, which means they have to fall within the IP range of your VPC. I'll just go back a second here. Your IP range is 10.0.0.0/16. Okay. So 10.0.0.0/16. I need to break up this large network into smaller chunks. Now remember, I told you that a 16 network is larger than a 24 network. So ideally speaking, you can actually break this network into smaller chunks of /24. For example, let me break this down into 10.0.1.0/24. Now my question is this 10.0.1.0/24, is this part of the main network? Is this actually an IP address in the main network, or is it not an IP address from the main network? Does this IP belong to the main network? Can someone give me a quick yes or no? Right. So it is part of the main network. How do you identify if it's part of the same network? You see the first network says /16, right? Which means the first and the second octet is not going to change. So let me take a look at this IP address. It says 10.0.1.0. Now 10.0 is the same, so it's not changing. It's definitely part of my main network. So whenever you're creating sub networks, guys, you have to make sure that you're creating it as part of your main network. If you have a 10.0.0.0, let me ask you this. I'm going to create a subnet like 10.2.0.0/24. Is this subnet part of the same network? Can I create the subnet in this VPC? It's not part of the same network because the 10.0.0/16 says the first 16 bits will always remain the same, which means it has to be 10.0. But here it's 10.2, which means it's definitely not the same network. It's a different network. So you cannot create such a subnet. So your subnets always have to be part of your main network. So in this case, I can go ahead and create 10.0.1.0/24. I can create a second subnet 10.0.2.0/24. Now, obviously, this second is also part of the main network. Also, when you create subnets, you have to create subnets that are not conflicting with each other. This network is different from this network, right? Because a /24 says the first three octets are going to remain the same. Now, when I look at my second network, it is different. It is not the same, which means it's not going to conflict. I cannot have another one here like 10.0.1.0 slash let's say 26. I cannot have that because I already have a network saying /24 with 10.0.1.0, right? So I've created another network with the same range. I cannot do that. I cannot create another subnet because it's conflicting with the first one that I created. Is this part clear, guys? I hope it is so. When you create your subnets, it has to be part of your main network, and it also should not conflict with each other. Okay, so now let's look at how the subnets are actually configured. Their availability zone. So I have 4 subnets here. Okay, so what I'll do is I'll create a subnet with 10.0.1.0/24. I'll create another one with 10.0.2.0/24. And when I go to the other availability zone, I'm going to ensure that I create a subnet a little bit differently in a different, there's enough difference between the first one and the second one so that as soon as I look at it, I can realize that, okay, this is in a different AZ because it's a completely different range, right? So I can do that. So you can have different ranges so that you can easily differentiate between different availability zones. Because if you do 10.1.0, 10.2.0, and if you did another 10.0.3.0 here, it might be difficult for you to figure out if they are all in the same availability zone or not, right? So that's just another way. It's not necessary that you have to do like this. This is just for your ease of doing things so that you can have a mental differentiation between all of them. So I'll make one public and I'll make the other private, and I'll make one public and the other one private in my VPC. So I have one public and one private subnet in each availability zone. So I'll put all my web servers over here, and I'll put all my DB servers over here. All right. And my web servers have external internet access through the internet gateway, but they do not have access to the database instances because they are part of the private subnet. Now, how do you define private and public subnet? So let's take a look at that. Let's take a look at how routing works within VPC. So let's bring back the same VPC. We have 10.0.0.0/16. We have a subnet here. We have another subnet here. We have an EC2 in the first subnet, which has an elastic network interface attached to it. It has an IP. We have also another instance which has a network interface attached to it with another private IP address. Now we have the router that sits within the VPC. We have an internet gateway. We have the route table. Now, how this works is pretty simple. When um, when one EC2 wants to communicate with another EC2, let's say this system, which is 10.0.1.35, wants to communicate with 10.0.3.48. Here's how it works. 10.0.1.35 makes a request to the router saying, I want to talk to 10.0.3.48. The router will then go to the route table and look at it if there is any routing information in it. Now, the first table says 10.0.0.0/16, the routing is always local, which means any system requesting for any IP in this range, the communication is local. So you can search for the system locally, which means you don't need to send it out to the internet. So when the router has this information, it looks up the route table. It says, okay, this system, which is 10.0.1.35, is requesting for 10.0.3.48. Now 10.0.3.48 is obviously part of 10.0.0.0/16. It is part of the main network. So then the communication happens locally. It does not have to go out. The router obviously already knows which systems are locally there. So it will route it to that particular system. This is what the route table does. Now, let's say this system wants to communicate with, let's say, an IP address out on the internet, and let's say that IP address is 53.19.1.4. Okay, that's the IP address, 15.19.1.4, 53.19.1.4. So this system requests to the router to talk to 53.19.4. The router goes ahead and looks up the route table. When it looks at the route table, it does not match this because obviously 53.19.1.4 is not part of that first one. However, there's another route in the route table which says any IP. What happens here is you have an entry in the route table which says every other IP. So if there is no match in any of the rules, if there is no match in any of the rules that have already been specified, it will go ahead and send it to this range, which is any IP. Now, what is the destination over here? The destination says internet gateway. So 0.0.0.0/0 is actually any IP, and the destination is internet gateway. So then the router forwards that information to the internet gateway, which then goes out to the internet and connects to that IP. So this is what the route table does. It has information as to where that information is supposed to be forwarded to, so that the router can forward it and then it gets carried forward from there. Now this 0.0.0.0/0, it's basically any IP. So if none of the rules in the previous ones match, it will go ahead and send it to that IP address. Now I want to take this one step further, and we'll talk about how we make something public or private. Now let's say, again, I have these two things and I have two route tables. I have a public route table and I have a private route table. Now, why is this route table called private? Because if you look at this route table has only one entry which allows local communication. There is no other entry in this route table to send the information out to the internet, which means there is no association of any internet gateway. There's no association of any NAT gateway as such. There's only one route, and that is local, which means any query that is coming to this route table, it will only allow the communication to be private. However, if you look at the public route table, it is exactly the same one as we have discussed before. It has a public route which sends it to the internet gateway for any IP that is not local. That is, any public IP, it will send it out to the internet gateway. Now, when I go ahead and associate a route table with that, I went ahead and I associated the public route table with this subnet, then this subnet becomes public, right? Before that, this subnet is just another subnet. Okay. When I associate that route table with that subnet, it becomes a public subnet. And when I associate the private route table with this subnet, it becomes a private subnet. Now let's look at what happens with the private subnet. Let's say this private subnet system 10.0.3.48 wants to communicate with 10.0.1.35. So the request goes out to the router. The router checks the route table associated with that subnet. Okay, that subnet has a particular route table association. The router checks for that. It sees that, okay, it's part of this 10.0.0.1.35 22.0/16. So I will send the communication local, then the communication will be sent locally. However, let's say this system is now trying to request for an IP that is outside 52.19.1.4. Okay. Let's say it's trying to reach that IP address. So it sends the information to the router. The router comes and looks up at the route table. It does not see any route for that IP. That communication will be denied. There is no outside internet access. Same way, there is no internal access as well. The internet gateway cannot send anything to this system because there is no return route. So this is essentially a private subnet. So any systems in this subnet, they can communicate with other subnets in any other availability zone as long as it is part of the local routing. However, they cannot communicate externally because there is no external access. But if you look at this scenario for this system, it is exactly the same like we described in the last slide, where if it wants to talk to the internet, there is another route here. It will go out to the internet gateway and then it can go out and then come back in. So I hope this concept of routing is clear, guys. I'll take a moment here. I'll pause and I'll ask if you have any questions with regards to how the routing happens. Just remember here is that the route table is the one that decides whether a subnet is a public subnet or a private subnet. By default, a subnet is neither public or private. It gets associated with a default route table. We'll talk about that. And anything within the VPC, by default, there is always a local route specified. So all the subnets within a VPC can communicate with each other regardless of what table they are associated with, because every single route table has a default local route. It's only when you want to decide whether you want to send it out or not that you have to specify an additional rule in the route table, which will actually send it out to the internet gateway. So does request from private subnet to router only check private route table? So it depends which route table is associated with the subnet. So if there is any system inside this subnet, it is obviously going to check with the route table that is associated with that subnet. If there is any system inside this subnet, it is always going to check the route table that is associated with that subnet. So that's what I mentioned. You have to associate a route table with a particular subnet, and it will always check the route table for that subnet, whether any systems in that subnet can talk to the outside world or not. Any questions before we proceed, guys? All right, I do not see any questions. I'll proceed. Okay, remember that you obviously, apart from the route table, if you need to make public communication, you obviously need a public IP address. All right. So apart from associating your route tables, your EC2 instance should also have a public IP associated with it, either a dynamically allocated IP or an elastic IP associated with it. But remember, even if this system in the private subnet has an elastic IP, it's still not going to be able to communicate because of the fact that the route table does not have that information. However, for information to come back in, you obviously need a public IP. Otherwise, that system is not going to be able to communicate with the internet. The role of DHCP. DHCP within AWS, it's actually assigned automatically. There's something called DHCP options, which I will show it to you when we do the labs. So there is always a default route table that is available inside whenever you create your VPC. The default route table, it's always local. It's always private, right? So there is no public route that is there by default unless you create an internet gateway and then you then you create an entry in your route table which goes to the internet gateway. Until and unless you do that, till that point, essentially your subnets are private, right? So until you do that, everything is private. So let's look at what NAT gateway is. So remember we spoke about NAT gateway a little bit before. which is we talked about whether a system inside a private subnet, if it wants to communicate with the outside world. So a NAT gateway is basically a managed service that AWS provides you, which allows you to make a communication or a connection out to the internet, but it will not allow any new communication to be initiated back into the subnet, right? Unless it was actually requested by the system in that subnet, it's not going to allow any communication to come in. This will allow your instances to actually do any kind of patching or updates or anything that it needs to do. This works, the NAT gateway works only for IPv4. If you want to do IPv6, same way, there is something called egress only internet gateway, which I'll show you when we do the lab section. So let's look at how NAT gateway works here. The similar configuration here, guys, except that the public route table and the private route table here is that in the public subnet, instead of your regular instance, you have something called a NAT gateway, right? And if you look at the private route table now, there's a new route here, which says, let me just update the color here, guys, 1 second. In your NAT gateway, there is a new route here. In your private route table, there's a new route here, which is actually out to the internet. So let's see how this routing works now. Let's say there's an IP address of 52.19.1.4. And let's say this system in this private subnet wants to now communicate with this IP address outside on the internet, which is it's the patch server and it needs to contact the patch server. So now this request goes out to the router. The router looks up the route table and it sees an entry for any IP or any public IP, and the destination is NAT gateway. It's not the internet gateway. So then this request gets forwarded to the NAT gateway. Now the NAT gateway already knows what to do because it's a managed service. You don't need to configure anything as such. This NAT gateway will now forward that communication out to the internet. Now obviously when it sends it to the router looks at the route table, then it forwards it to the internet gateway. So you see how this works. It is basically this, and this, right? So this is how the NAT gateway works for systems inside your private subnet. So if you have any systems inside your private subnet that wants to access the internet, this is how you set up the NAT gateway. Any questions here, guys, before we proceed of how the NAT gateway works or anything like that? So there's a question about what is a bastion host. A bastion host is, for example, let's say the same case where you want to connect from outside, you want to log in SSH into this system, right? Obviously, you don't have a public route and you can't do that. Even if you have a NAT gateway, you can't initialize the communication inside unless the system had requested it. So what you basically do is you actually put an EC2 inside your public subnet, you SSH into that, and then from that system you SSH into the system. So this is basically a jump host or a bastion host. So it's just to entry to routing table to create NAT gateway. No, you have to first create a NAT gateway, and then once the NAT gateway is created, you have to update that information in the route table so that it can start routing to the NAT gateway. Right? So let me move on. Okay. So some key points to remember here is that VPCs are limited to a region, but they actually stretch across all the availability zones. Subnets can be private or public and are limited to a single availability zone. So remember, your subnet is always inside an availability zone. All right. Subnets must be associated with a route table. Without a route table, it's not going to be able to route any information anywhere. An internet gateway route must be added in the route table for internet access inbound and outbound. So without internet gateway, there's no way you can communicate with the internet unless, of course, you're using a NAT gateway. A NAT gateway can be used to simulate the DMZ zones, which is allow where inbound public access is blocked, but external access is allowed. And remember, 5 IPs are reserved, so 5 of them are not usable when you create your VPCs. Now, the NAT gateway, it's a managed service. It is not an EC2 instance, which means you're paying for it as a service. You don't need to configure anything as such. Like, you don't need to log into the NAT gateway to configure any kind of routing or anything like that. However, um, before the NAT gateway was introduced, what people used to do is they used to have an EC2 instance, all right, which had the same functionality of what NAT gateway does, but you had to configure that on the software level. So you, on the software level, you will configure all the routing, which is like you have to disable something called source destination check, right? You disable those things, and you can actually do additional things like IP filtering, intrusion prevention, detection, all of those kind of things additionally on an EC2. But you have to manage this EC2, you have to configure it, you have to update and patch it, you have to look up all the rules, everything has to be managed by you. So instead of that, what they started offering is, without you having the headache of running an EC2, they provide you a managed service as the NAT gateway, where you just put it in the route table, it'll handle all the requests for you. NAT gateway used for only for private subnets. NAT gateway is used whenever you do not want inbound access to your systems, but you want to allow outbound access, right? So technically speaking, that is a private subnet, because a public subnet by default has public access inbound, right? So there's no point in having a NAT gateway in a public subnet. All right. So now let's talk about VPC endpoints. Um, some of the services that are available on AWS, something like Amazon S3 or even DynamoDB, although they are on AWS, when your EC2 instances are talking to them, they actually have to go out through the internet gateway and then come into S3 using the public endpoint. So this is what I mentioned before, that it's not necessarily a good option, because you are traversing the public internet. Although, you're still using HTTPS and you're securing your connection and all of that, however, it's still traversing the public internet, and you don't want that happening if you want to actually transfer data that is highly secure. So anything that you're trying to communicate with, normally with S3, it goes out to the internet gateway and then goes to Amazon S3. What VPC endpoints do is it creates something like an internet gateway. It is a gateway, so to speak. It's a endpoint. All your instances will now talk to the endpoint, and then through the endpoint, it will connect to S3. The difference here is that this communication is in the private network, within the AWS private network. It is not going out to the public internet. So the communication that you have here is much, much more secure than what you generally get when you're trying to use a internet gateway to communicate to the services. As of now, you can use VPC endpoints with Amazon S3 as well as DynamoDB. All right. Now, there are some other services, however, which uses something called endpoints, but it is a little bit different. It's known as interface endpoints. So the services are things like when you're using the API calls for your EC2, or when you're using the service catalog application, or when you're using Elastic Load Balancers, when you're using the EC2 Systems Manager, Kinesis streams, CloudWatch logs, encryption for KMS, and the SNS notification system. Same thing happens before. When you used to communicate, this has to go out to the internet gateway, then it talks to all of these services individually. It's going over the public internet. However, now with the option of something called interface endpoints, what happens is there is an ENI that is actually created for each of these services, and then that is mapped to that ENI. So now your ENI has a private IP address, so something like 10.0.15.0, 15.10, something like that. So each of these ENIs have an IP address, the local IP address that is associated with them. So now when your communication happens, it is private here. And obviously this is also private because it's not going out to the internet. So these are the two things between endpoints and interface endpoints. Endpoints, basically, you just have a gateway and it goes out to the gateway. In interface endpoints, the difference here is that these are the other external services where it creates certain elastic network interfaces within a subnet, all right? And then all of them are mapped here. And when you communicate with those endpoints, it is actually going to go out through those ENIs and it's not going to go out through the internet gateway. With that said, I just want to quickly show you a slide that was recently there in the reInvent session by Amazon back in 2017, which is all the different things that have changed. So if you look at this, these are the new features that are available on the AWS VPC as of today, which is they introduced IPv6. There is something called security group rule descriptions, which we'll discuss. Um, there is support for CloudWatch metrics now for all VPN, Direct Connect, and NAT gateway. All the private link services, which I kind of already mentioned, the ENIs, which are created for all of these services, ENIs get created in each of the subnet. Then you have VPC endpoints that are there, which connect to S3 and DynamoDB. They introduced inter-region VPC peering, which means you can now connect multiple VPCs together, even if they are across a region. We will touch on Direct Connect and Direct Connect Gateway and expanding your VPC. So this was recently introduced feature as such. Like I mentioned, if you already specified a CIDR range, you can expand your VPC by specifying another CIDR range. So you don't have to be stuck with a single CIDR range that you happen to specify initially. Before, this was a very large problem before, because sometimes you had ended up creating an VPC which was pretty small, and then you realize that you run into these issue constraints of not having enough IP addresses. All right, I will pause here for a moment and ask if you have any questions before we proceed. For CloudWatch logs, yes, we have an ENI available. So when you're sending and receiving logs from CloudWatch, now you can securely send it through the securely send it through the ENIs that you connect via the interface endpoints. You don't have to talk to the CloudWatch as a public service. All right, guys. So I'm going to go into the VPC labs and I'm going to quickly show you how to set up a VPC and configure everything with regards to setting up subnets and all of those. Um, I'm going to go at a medium pace. So if anybody wants to try this along with me, please feel free to do so. Um, I'll give you enough time so that you can complete it, but I'm not going to pause for long. So unless you can keep up, I wouldn't suggest you do this. But if you want to try it, go ahead. So let me go ahead and quickly log into my console so that I can show you how to do this. Just give me 1 second. All right, guys. So I'm in my console right now, and first thing I'll do is I will go into VPC. Okay, so this is basically your VPC dashboard. You have an option to use the VPC wizard in order to create a VPC. However, that's too easy, and you might not understand what's happening behind the creation of the VPC. So what we'll do is we'll go to your VPCs over here. And like I've already mentioned, you always have a default VPC that is available in your account in every single region. Guys, excuse me for 1 second. All right. So right now I'm in the North Virginia region, and as you can see, there's already a default VPC available there. Even if I switch regions, there will always be a default VPC, and almost all the time they're going to be a 172.31 range. So I'm right now in Ohio. As you can see, there's already one there default, and there's another one which I probably created some time ago. I might have to delete it. So let me come back to the North Virginia region, and I will create my VPC over here. All right, so I will hit create VPC, and the first thing it's asking me is for a name, and it's asking me for the CIDR block. So I'll just give it a name as in webinar. I'm going to stick to the same CIDR block that we kind of discussed, which is 10.0.0.0/16. If you want, you can assign IPv6. Assigning it right now, I'm not going to show you the IPv6 right now because that's another subject altogether. I will discuss that in the part 2. But when you do this, you are going to basically allow IPv6, right? So if you want to switch this on, you can just put it to Amazon provided IPv6. Now, again, this is the IPv6 address that AWS gives you. So you don't get your own IP address. This is basically a /56 IPv6 block. All right. You have a /56 IPv6 block for your VPC, and then you do /64 for your subnets. This is the tendency that I was talking about, which is default means you're just going to use the existing network hardware. You're not going to have dedicated network hardware. But if you select dedicated, they are going to give you dedicated network hardware. However, this is expensive, right? So unless you are an organization that requires this, you should not be selecting this option, and you can go with the default option. Make sure when you're creating it, you're doing it with the default, because if you don't do so, you won't get some other options later on. So once again, I'm doing webinar as a name, 10.0.0.0/16, Amazon provided IPv6 block, tenancy is default, and I create it. And there you go, it's created. So as you can see, it's already assigned that block to me. It's also assigned a /56 block for the IPv6 addresses. So now that I have my VPC, the next thing I need to do is I need to create subnets, right? So I'm going to go into subnets, and I'm going to create subnets. Here's what I'm going to do. I'm going to follow the same model that I showed you on the slides, which means I'm going to create one public and one private subnet in each availability zone, in two availability zones, right? So total of 4 subnets, 2 public and 2 private, in which one subnet will have one public and one private. However, like I mentioned, when I create these subnets, they're actually not automatically becoming public or private unless I'm assigning them to a route table. All right. However, just for clarity, I'm just going to name it public. I'm going to say public 1A, right? And I'm going to make sure I select my VPC here. And I'm going to select 1A here because I already typed in the name as 1A. And the IPv4 block, it's going to be 10.0.1.0/24, because remember, I'm creating a subnet within my /16 VPC. And to keep things simple, I'm just going to use the /24 here. But obviously, you can use anything under /16, right? It's not necessary that you have to use a /24. You can do a /19 or etc., whichever you wish to. But to keep things simple, I'm just using this one. It's asking me whether I want to assign an IP CIDR block, V6 CIDR block or not. I'm just going to leave this out for the rest of the session because managing IPv6 is a different thing. So I will do that. So I'm going to create 3 more, and I'm going to call this private 1A. Make sure it's in my subnet. I'm going to make sure it's in 1A, 10.0.2.0/24, 8. So I'm going to create another subnet, and I'm going to call this public 1b. So I created public 1a and private 1a. So now I'm creating public 1b and private 1b. So because I said I'm giving the name as 1b here, I'm going to make sure that the availability zone is also 1b so that there's no confusion. And I'm going to go with 10.0.20.0 slash 24. Hitting it. Create the subnet, which is private 1b. 1.0 slash 24. Create. Okay, so now I have the 4 subnets that I require. Now, just to filter out this view, I'll just go ahead and type in webinar over here so that it shows me only the subnets that are associated with my VPC. So as you can see here, I've created 4 subnets: private 1b, public 1b, private 1a, and public 1a. And you can see what are the different CIDR ranges on it. And as you can see, it shows 251 IPs available, because remember, 5 IPs are not usable in each of the subnets. Out of 256, if you take out 5, that essentially becomes 251. There's a question: can we get recorded video? Yes, this is actually being recorded right now, and hopefully once the session is over, I should be able to put it up on YouTube, but I'm still considering that because this was supposed to be a private session. All right, so I have the different availability zones here, all the different things, the route tables and everything. All right, so I created the subnets here. Now I need to create an internet gateway, because before I assign anything to the route tables, I need to create an internet gateway. Otherwise, my route table right now, if I go into my route table and if I see the route table that is associated with my VPC, which is this one, right? And if I go to routes, as you can see, there is 2 routes. One is IPv6 and one is IPv4. As you can see in the IPv4, there is this single route for local. There is no external route. And it says that it is the main route table. So remember, this is kind of the default route table. So if I create any subnets, that will automatically use the default route table unless that subnet is associated to a particular route table. All right. So first I'm going to do is I'm going to create an internet gateway. I'm just going to call it simple as that. Just go ahead and create an internet gateway. Once you create an internet gateway, you need to attach it to your VPC, because you already have another internet gateway that is attached to the other VPC, right? So I'll attach this. Otherwise, my VPC will not be able to communicate outside because I need to attach it. I have attached my internet gateway to my VPC. All right. So now let me go back to my route tables. Now I don't want to use this default route table, right? I want to create separate route tables for public and private. So I will create a route table and I will call this public route table. And I'm going to associate that with my VPC. And I'm going to create another route table and I'm going to call this private route table. Okay, so as you see here, I've created 2 more additional route tables. At this moment, there is no subnets that are associated with these route tables. And I will show you what the routes are. So if I go to private route, again, it is only local communication. If I go to the public route, also it is only the local communication, because by default, when you create a route table, it's local. It doesn't assign any outgoing paths. Now, if I go back to the that we were discussing in terms of private and public. So I have 2 two private subnets and two public subnets that are in different availability zones. Now I have created two route tables. I have created a public route table and a private route table. But as you saw there in the public route table, I still have not configured the internet gateway, right? So I will go ahead and do that, which is I will go ahead and add the internet gateway route. So I go to my public route, I'll go to the routes tab, I will edit the routes tab, and I have an option to add a route here. So I'll click on add another route. And here, if you remember going back to the slide, that basically tells me the route is going to be 0.0.0.0, which is every other IP. So 0.0.0.0/0. And where should I be sending this, guys? Anybody can quickly tell me where exactly should I be sending this traffic to? What should I be mentioning in the target box here? Still awaiting for your inputs, guys. Right. I should be specifying the internet gateway here. Now, because I have already created the internet gateway and because I've already associated it with my VPC, as soon as I click on this box, I get the option here for the internet gateway, which is IGW, right? Now, if you did not already attach your internet gateway to your VPC, you will not get this option. And obviously you cannot add this. But as soon as I click on this now, it's already there. So I click on it and select it. There you go. And I will save that route. So as you see here, now the difference between my public route table and my private route table is that in my public route table, I have a route that goes out to the public internet via the internet gateway. However, in my private route table, I have no such route. It is only going to do local communication. Now I'm going to associate these subnets with this route table, because as of now, all the subnets are going to the default route table. So I will go to subnet associations. I'm editing my private route table. So I'll go to subnet associations. I will edit this and I will go ahead and select the ones that say private. So here's what I'm doing. I am associating my subnets with my route table. I'm making that connection now. So when I hit save, now these two subnets that I just selected have actually become a private subnet. These two subnets, which is private 1A and private 1B, are now private subnets because I have associated them with a route table that only has local routing. It does not send anything out to the internet. I will do the same thing with the public route table. I will go to the subnet associations. I will edit it and I will add the public route tables over here. So I will save that. So now I have made public 1A and public 1B as public subnets because I have associated those two subnets with my route table that actually has a public entry in it. All right. So now is how my subnets get differentiated as public or private subnets. Till that point, it is the default subnet, which is again only private. Now, whatever I put in my public subnets, which is if I go to my subnets here, now whatever I put in public 1B and public 1A, those systems should be able to communicate to the internet. But whatever I put in private 1A and private 1B, those will not be able to connect to the internet. Now, what we will do is I'm going to go ahead and launch some instances to this. Okay, route propagation is used when you're using something called BGP, where automatic route propagation happens. So again, I will kind of touch on this when we talk about VPN and direct connect. You use it mostly when you're using BGP protocols, where essentially this route is getting propagated to every other router in the network, right? That is talking to this particular VPC. So at the moment, we don't have this VPC connected to any other network. So obviously there's not going to be any route propagation and we are not using BGP. So that's not going to happen. So I'll touch on that a little bit later on towards the end of our session. Okay. So now I have my route tables, I have my subnets, I have my VPC, and I have my internet gateways. Okay. I'm going to go ahead and launch a few systems. So I'll go to EC2. Okay. For some reason, I have a running instance there. I will terminate that. Okay. So I'm going to launch an EC2 instance, and I'm going to put one instance in the public subnet, and I'm going to put one instance in the private subnet. And I'm going to show you how that communication is going to work. So I select E2.micro, I go next. Now it's important to remember here that I go select the my VPC, and I'm going to put it in public 1A. Okay, one thing I forgot to do before I do that. When you create your VPCs by default, it does not actually do DNS host names resolution, right? So as you see here for my VPC, it says DNS host names is no, which means I cannot use any particular host names for my systems within that VPC. It's not going to work. So let me change that to yes. So I just select the VPC, I go to actions, I go to edit DNS host names, and I set that to yes. So now I can launch instances with host names. Otherwise, before that, it's not going to work. Only IPs is going to work. So I select my VPC here. I select public 1A. I will assign it an automatic IP address. I'm not assigning it an elastic IP. I'm just assigning it a dynamic IP. I will show you later on how to assign an elastic IP. I'm going to assign it a role. Now, if you don't know what a role is, that's basically some permissions for accessing other services on AWS. All right. So I'm giving that some permissions because I need to show you a command line interface. And I'm going to next add storage. Syntax. Name. Okay, I'm going to create a new security group here. I will discuss in detail what security groups are, guys. Just so hold on for a second. So I'm just going to create a new security group here, which is giving me access to the SSH on this system. All right. So I'm going to review and launch. I'm going to launch it. I am also going to launch a second instance, and this instance I will be launching it in the private subnet. So I will go to private. I will do it in private 1B. Okay, because this is a private system, I'm not going to assign a public IP to it because it's in the private subnet. Even if it has a public IP, it's no good. I'm not giving it a role right now. Start storage, next tags, add tag. Name is webinar private. Now, because I already created a security group, I will assign it the in fact, I will create a separate security group because I need to show you how communication between security groups actually happen. So I will do this as private. Obviously, this is a private system, so I'm not going to allow SSH as of now. Okay, just give it a second as the systems come back up. Okay, so first I'm going to go connect to the public system. So as you can see, the public system already has an IP address because I assigned auto assigned public IP. So I'll copy that public IP address and I'm connecting it via putty here. As you can see there, I went ahead and logged into that instance by using the public IP address. All right. Now this public IP address can, sorry, this public instance, because it is in the public subnet. If I say ping google.com, as you can see, it is pinging, right? That. Now, also, if I try connecting to the private IP of the other system in the private subnet, right? So this is the private system. I'm going to connect, try to ping it. I'm not getting a response. Any idea why? Okay, so this is where security groups come in, guys. So I'm going to take quickly, I'm going to move away from the labs for a few minutes and I'm going to explain the concept of security groups here. Give a second. All right. Okay, so there are two parts to the security on VPCs. One is something called network access control lists or NACLs, and the other one is security groups. I'm going to cover security groups now, and I'll show you the NACLs in the practical section of it. So when we look at our VPC and when we talk about our subnets, we have our EC2s that are there inside those subnets, right? Each of the subnet, each of the instance is actually protected by something called a security group. Now, remember that this is actually protecting, the security group is actually protecting the individual resources that it is assigned to. For example, I have another EC2 in the same subnet. Even if I assign that EC2 to the same security group, it is still going to have, it is still going to cover that EC2 instance individually. And if I have another instance with a different security group, that is obviously going to cover that instance as well individually, right? Now, I want to take this a little bit further and explain this. Now, you have security groups here. Now, security group 1, I have assigned to 2 instances, and security group 2, I have assigned to a third instance. Now, remember that the properties of security group 1 is exactly the same. Okay. Security group 1 is security group 1. There's no two versions of security group 1. It's exactly the same. So if I say allow port 80, okay, security group 1 is going to allow port 80. This security group 1 is also going to allow port 80. However, remember I told you that each of the instance, each of the resources individually covered by the security group. What I mean by this is if instance number 1 wants to communicate with instance number 2, technically what's happening is the communication is going out from the security group, then it is re-entering the security group. Okay, it's not a internal security group communication. It's literally exiting that security group and coming back in. Now when I say this, I'm not saying that technically that's what's happening, but I want you to understand the concept behind this. Because if you want system 1 and 2 to talk to each other on, let's say, port 22, which means I want to SSH from system 1 to system 2. If I have to allow that to happen, I have to have a rule in my security group saying that port number 22 should be open for security group 1 to security group 1. Although it is the same security group, I still need to specify that rule, because technically what's happening is if I'm trying to communicate with another instance within the same security group, it is actually leaving that security group and re-entering it. So if I don't specify this like a re-entry, it's not going to work, right? It's not going to allow the communication to happen. So I need to open ports for the same security group to itself. Otherwise, sometimes the internal communication is not going to happen. Obviously, if I want to do security group 2, like if I want to do port 22 inbound on security group 2, I have to allow port 22 from security group 1 to security group 2. I have to allow that. All right. However, if instances between security group also wants to communicate with each other on port 22, I still need to allow that, saying security group 1 to security group 1 should be allowed access to each other. All right. What's happened right now is my first instance, I have one security group, and my second instance, I have another security group. When I'm trying to ping this system, it's not working because I have not allowed any kind of rules for the security group at this moment. One important thing to understand here is that the default of a security group is to allow all outbound, deny all inbound. That is the default of a security group. All right. So it's allow all outbound, deny all inbound, which means you don't have to specify rules for outbound communication because it's all allowed by default. Of course, you can change that. However, if you want to allow anything inbound, you have to specify that separately in order to allow the inbound. So my private instance is in security group 2. So I should have a rule that allows security group 1 access for the ICMP port for pinging, right? Otherwise, it's not going to ping because it's not going to allow it. Now, the best thing to do here is rather than allowing individual systems, it is better you give access to the whole security group. For example, I have my EC2 instance here in the private EC2 instance, and I want all the systems to be able to ping it, right? So I will give inbound access for SG1 for ICMP protocol. Then what happens is, even if it is this system in SG1 or even if it's this system in SG1, it is should be able to ping it because it is actually allowing SG1 and not individual systems. So it's always better you allow security groups as a whole rather than individual instances, because if you allow the security group as a whole, you can allow any group, any instance that is associated to the same security group access to the resource. I'll just show you this in a little bit more detail in the labs here. So I have my private and my public one, right? I will go to my private EC2 instance and see it's actually associated with my private security group. So I will go there. This is the security group editing option, guys. So I'll go to inbound. Now I am in the inbound rule for security group 2. Okay, so I am allowing open inbound access on security group 2. So I will edit that. I have an option for ICMP here, but I'm not going to do that. I'm going to do all TCP, okay? Because those are systems that internal systems, so it's fine. I can allow it. But of course, if you want to specify a certain protocol as well, you can do that. But I'm not going to do that for now. All right. I'm just going to do, I can do a custom ICMP rule here if I wish to, but I'm just going to do it all TCP. So here I have to specify the source. Now, if I type in SG, there you go, it shows me all my security groups. So I'm allowing any instance in the webinar security group access on all the ports into this security group. That's what I'm doing. I'm allowing access to all instances in the webinar security group into this private security group. So any instance in this should now be able to talk to each other. Now, one more thing about security groups is that security groups are, it can actually allow the communication back in on the same port. For example, I have my EC2 in the private subnet here, and let's say I want to talk on port 25. Okay, and I have another EC2 here. Now this system in SG1 talks to this system on SG2 on port 25. I have an entry over here that says allow SG1 access on port 25, so it is able to allow it. Now when this communication comes back in, I don't need to open a port here for 25. I don't need to do that. I don't need to do that for security groups, because it knows that this is the same communication that went out. So it'll actually allow that communication back in. So I don't need to specify a second inbound rule here. It'll automatically allow that rule back in for any rule that is specified out. Obviously, it has to be coming from SG2 itself. All right. It should not be coming from any other security group. It's not going to allow SG3 to come back in on port 25 if there is no rule here. Technically, what I'm trying to say here is that if you allow an outbound rule for a particular port, by default, it will allow that inbound rule as well for the same resource. Okay, not for different resources. So if port 25 is allowed on SG2, it will only accept port 25 back in from SG2. All right, not the other way around. So if I go back to my, okay, so I have allowed that. So now let me try pinging it again. Interesting. What did I miss? Okay, instances, webinar private, webinar public. Private is allowed all inbound. SG, save. No, by default, SSH is available in all of them. This is a networking issue. That's why it's not able to ping it, right? It's not a application issue because it's not able to ping. So it's not responding to the ping, right? Let me check what else is wrong here. 10.0.21.107. Okay, I don't know if this is a security group related issue. I'll just open that up. Oh, okay. I see what I did wrong. Okay, I actually allowed all TCP. I should have allowed all traffic because pinging is ICMP protocol. So obviously it's not TCP protocol. So that's why it was not working. So I'm allowing all traffic and I'm saving it. Now if I ping, there you go. It's actually pinging now. So obviously it was ICMP. That's why it was not pinging. I had selected all TCP instead of all traffic. All right. Okay. So let me now show you. Just give me 1 second, guys. Let me just get onto the other system. All right, guys, there's some issue with my putty settings here. So I'll come back to this towards the end of the session. So for now, what we'll do is I will go ahead and create some S3 endpoints and show it to you how it works. Okay, one thing I want to show you is assigning elastic IPs. It is pretty simple, guys. When you want to assign elastic IPs, is go to elastic IP, allocate a new address, Okay, so you got a permanent IP. Once you get the permanent IP, you just need to associate it with an interface. All right, so I will refresh that. I will associate the address. So I will associate it with the network interface of either one of the instances, or if I select instance, I will get the instance ID, right? So I can assign it to the private one if I wish to, but I'm not going to be doing that because obviously my EC2 instance is in the private subnet. Second. All you need to do is once you do this and you hit associate, that system is going to get that IP address. I'm just going to show it to you over here once. Now, if I go refresh my EC2, as you can see, my private EC2 instance has now an elastic IP attached with it, but obviously it's of no use because it's been my private subnet, right? I cannot make use of that unless I enable an internet route out to the internet gateway. So that's all with regards to elastic IPs if you ever need to assign one. Obviously, you need to disassociate the address if you need to delete it. So disassociate and then release it. So those are two steps. First, you acquire the IP and then you associate it. And once it's associated, you disassociate the IP and then release it, right? If you want to ever use that. Endpoints, like I mentioned, if you want to talk to S3 or something privately, that's the way you have to go with endpoints, where you can directly communicate with the service over the endpoint rather than going over the internet to communicate with the S3 buckets. For example, if I create an endpoint here, it's asking me what do I want to create the endpoint for. So it's either an AWS service, or I can find other services, or there are actually marketplace services. So the marketplace service and service provider part, guys, this is actually part of the part 2 session, because this is talking about using endpoint for public services. So that's different. For AWS services, as you can see here, there is DynamoDB and oops. So in this list, if you look at gateway, you have DynamoDB and S3 shown as gateway. So these are basically the VPC endpoints. And if you look at all of the other ones, it says as interface. So if you remember, I kind of touched on the interfaces as well, which is endpoint interfaces, which actually creates an elastic network interface inside a subnet. So for all the other services, which is EC2 APIs, messages, elastic load balancing, service catalog, all of these, you can actually do the interface. And for S3 and DynamoDB, you will have to do the endpoint. All right. So I'm not activating this right now because my putty is not proxying onto the second system. So I'll come back to this particular section once we are covered with all of the other topics, guys, because I need to show you getting onto the private system and then making use of this endpoint. All right. So I will cancel that for now. DHCP option sets. So this is basically where it allows you to configure the DHCP options. Now, remember, there is the IP address, which is .2 that is reserved for the DHCP within the AWS network. So if you would like to configure custom DHCP settings, for example, if you want to give your systems custom host names with your custom domain names, you can actually do that. If you're also using, let's say, a Windows system which has its own DNS server, you can actually read out all your DNS queries to that server and not use this one. So this is where you actually configure your DHCP options. Almost all the time, unless you have your own custom DNS server, you're not going to touch this. You're just going to leave it at the default. This will be covered as part of the second section, where we are going to show you more advanced, in depth, where using a DNS server and how you will route all the how you will route all the DHCP queries to that DNS server. All right. So if you have any custom DNS servers that you need to mention here, you can do that. But right now we don't have any custom DNS servers, so put that for the next section. All right, let's talk about NAT gateways. So we have a private system that does not have communication out to the internet, right? So again, let me fix that proxy thing with my putty and I will show you this. So for the time being, guys, once I fix the proxy part, I'll come back to this, but I'll continue with the remainder of the theory part. I'll come back to the practicals once again. Okay, I'll pause here for a second and ask if you have any questions for whatever we have covered so far, guys. Okay, let me quickly show you the network access control list. So whenever you create your VPC, it has certain inbound and outbound rules that are associated with the VPC, and these are also associated with your subnets. Okay, these are basically known as NACLs, network ACL. This is nothing but you're just specifying what port is allowed inbound and what port is allowed outbound. Now there are a few difference here between NACLs and security groups, so I'll just show that to you on the slides here. The security group, like I said, it operates on the instance level, while the network ACLs actually operate on the subnet level. All right. The security group allows only allow rules, which means you can't do deny rules. By default, in the security group, it's all allow outbound traffic. Okay, which is the third one here. Allow rules, allow outbound traffic, but it is inbound deny. So we have to allow the inbound on the security groups. On the network ACLs, you have to specify both allow and deny rules. Like I've already mentioned, security group is stateful. So return traffic is automatically allowed. So you don't need to specify any particular ports for return traffic for that same security groups. However, for the network ACLs, that's not the case. It is stateless. You still have to specify which port should be allowed back in. In security group, it looks at all the rules before it decides what to allow and what to deny. In network ACLs, it looks at the rules one by one and then either allows it or denies it. I will show you this in the console. Just give me a second. The security group applies to the instance only if someone specifies it. But the network ACL applies by default. No matter whatever you're doing, it applies by default to the subnet. So when you have a subnet, it'll apply by default to it. Security group, unless you assign a particular security group to an EC2 instance, it does not get applied to that. There's no default in that. Now I'll just show you the NACLs here. Okay, so you see these are the inbound and outbound rules for the NACLs. Okay, unlike security groups, the first rule is allow all traffic inbound. Okay, that is for IPv4, and this is the second rule for IPv6. After that, you can see there is a rule which says all traffic deny, all traffic deny. So there is both an allow and deny rule. So how is it still working? Because in network access control lists, it goes line by line. So it looks at the first line. If there is a rule that allows it, it's allowed in. Okay, it doesn't look at all the other rules. So when you are actually specifying rules here, you have to be careful, because you have to put your most highest priority rules on the top, because it executes one rule at a time. It doesn't look at all the rules together. Unlike security groups, where if you have 10 rules, it will look at all the 10 rules together, and then there is if there is a deny, it will actually deny it. It doesn't look at one by one rule. Same thing applies for the outbound for network access control list as well, where all outbound is by default allowed as well as denied. So it looks at the first rule when some communication comes in and it allows it. So you have to be careful in terms of specifying the rules here. When you do specify the rules here, I would suggest that you leave at least some space between the rules. For example, this is rule number 100. Okay, and this is rule number 101. Don't create another rule with 102. Rather, create a rule with something like 200, so that if you have to create another rule in the future which is taking higher priority, you can create it between 100 and 200. Okay, so let's say you have a new rule that you created, and let's say you created it as 102, but then you have a new rule that you want which is supposed to be higher priority than 102, then you can't do anything. You have to literally replace that rule, right? So that's not a good idea. So leave some space between the numbering. So do 100, 250, then do 200, then do 250. So leave some numberings in between, so that if you have to plug in a particular rule in the future with a higher priority, you can plug it in without actually having to change or delete anything. All right. Any questions between security groups and network access control lists? NACLs. Remember, the NACLs apply directly on the network, on the subnet level. The security groups apply only on the instance level or on individual resources, whether it's your EC2 instance or your RDS instances, whichever they are, they apply on it individually. Why Elastic IP does not show in EIP tab, but shown in IPv4 public address? You mean to say here? There is no other EIP tab. Any public IP, whether it is a Elastic IP that you assign, or whether it's the automatically assigned IP, that is going to show up here. If you have multiple IPs, that is also going to show up here. So I can attach multiple IPs to the system. That's always going to show up here. So it depends on how you're working with the NACLs and the security groups, on what applications you're dealing with. Remember that with security groups, there is no deny, there is only allow. Okay, so you're just dealing with one side of the things, so it doesn't really give you control over the deny part. You're, because by default everything is denied, you're just allowing it one by one, right? Having said that, do understand that the security group is the first layer of defense. So you have to make sure that your security group is configured as granularly as possible, rather than your network control, network access list. So this is how you add the rules, guys. Just come to the NACL. You can add another rule here. You can give it a rule number like 200. You define what is the protocol or what is the port. You define the protocols again. You define the port range, whether it's a single one or all of them. Then you define the source as well. All right. Obviously, I'm not going to specify that now. Okay, let me quickly wrap up with the remainder of the PPT, guys. Okay, so let's look at the two other aspects that I told I will cover in detail in the second section. One is VPN and Direct Connect. Now, AWS offers VPN connectivity into your VPC. You can actually make the connection using IPsec protocols. It can either be static routing or dynamic routing. It is AES 128-bit encryption with SHA-1 hashing function. When you create an IPsec, when you create a VPN connection, you basically get two IPsec tunnels per VPN connection. All right. We'll take a closer look at how that essentially translates to. So let's say this is your corporate office on the left side, and this is your corporate office or your data center or whichever it is. And let's say you have an IP address range of 192.168.0.0/16. That is your local network range. And let's say you have a VPC with 10.0.0.0/16. You will establish a VPN connection between the customer gateway and the virtual private gateway, or the VPG. Once you do that, it actually creates two separate tunnels, which gets two endpoints on the virtual private gateway. All right. And the routing is pretty simple. The local network will advertise the routes to the VPN on the other side, and this VPN connection will advertise the routes this way. So now let's see if these systems wants to communicate with one of the systems in your corporate network. Let's say this one of the instances actually wants to communicate with 192.168.10.15. Okay. So that will come to the router. The router will look at the route table and it sees an entry for 192.168.0.0/16. And as you can see, the entry actually goes to virtual gateway, right? So that communication gets forwarded to the virtual gateway, that sends it to the customer router, then obviously the customer router will send it to the private IP as well. It's simple. It's same as what you would have with your um, route tables that you create for the internet gateway, etc. Right? As long as you have the routing information properly mentioned in the route table, that should be fine. Now this is static routes, right? This is static VPN, where you're assigning a certain static route onto your VPN. The problem here is that if a tunnel goes down, you have to manually work with this because it's not automatically going to fix or fail over to the other tunnel because it's static routes. In that sense, you can actually do dynamic VPN. When you do dynamic VPN, what happens essentially is BGP comes into play. Now, for those of you who don't know BGP, this is actually a networking term, which is Border Gateway Protocol, which actually is dynamic. Okay, it's has something called an ASN number. An ASN number is kind of the network path. So when you look at the number and you say BGP ASN is 17493, this is the number of AWS. All right. So this router that you have knows which is the route to take to go to that AS number, right? So what happens here with the dynamic VPN is the fact that you don't have to worry about tunnels failing and all of that because BGP has dynamic negotiation. If one of the tunnels fail, it has the capacity to actually switch over to the other tunnel as well, and you don't have to do any static routing here. However, the concept of route table still applies, where if you want to send traffic between your networks, you have to mention as to where it ends up. You will have a similar route table, obviously, in your router over here as well, which says all traffic destined for 10.0.0.0/16. It is supposed to go out through the VPN connection. All right. Any questions here on VPNs, guys? I will show you in the console how to create a VPN connection, but I was trying to set up a router over here for you to show you how this works. Unfortunately, that router failed today morning, so probably next session I'll show you how to do the actually apply the settings on the router so that you can see the VPN connection happening from both sides. Any questions here on VPN? Now, remember, I will be covering this in much more detail in the part 2 section of the webinar, hopefully another day. What is the benefit of attaching IP directly to EC2 to the ENI? Okay, I'll come back to that. Any questions on the VPN side, guys? All right. One more option you have is resilient VPN connectivity, which means you are having multiple customer routers. You have something called iBGP. You have something called iBGP, which does internal BGP between all your routers. And then you have your connection that is the eBGP connection that goes across to the internet, that goes across to the virtual private gateway. So as you can see here, you have resilient connectivity between both of your routers. So you have 4 tunnels across 2 VPN connections here that are terminating on the same virtual private gateway connecting to your VPC. When you have multiple VPCs, you can still do the same thing. where you can have literally multiple VPN connections that are spanning across both your routers that are connecting to both the VPCs, right? So in this particular webinar, it's all been about a single VPC, guys. So in the next one, we will be looking at how to go from one VPC to multiple VPCs, right? So in that, we'll discuss more about hub and spoke model of VPCs, things like transit VPCs, direct connect gateways, etc. All right, so let's talk about direct connect. Um, direct connect is basically an option for you to have physical connectivity directly into AWS. What you get is you get a direct dedicated connection that runs directly to the AWS equipment at one of the data centers that AWS is partnered with. All right, this is not inside the AWS data center, but it is with one of the partner data centers. This is a direct connection into AWS, which means it's a private connection. Whatever communication you're actually doing between your offices or your data centers and the AWS environment, it is going to be private. It's not going to go over the internet. It is going to go over that dedicated line that you have. It reduces your bandwidth costs very much because you're not paying for the public internet. You're just paying for a lower cost that you would pay for the dedicated connection bandwidth. Now remember, it doesn't mean that the actual connection is cheaper, because sometimes the dedicated networks actually do cost more in terms of setting up. However, bandwidth costs are much more lesser than how much you would pay for a internet bandwidth. You get consistent network performance because this is a private connection. It is not going over the internet again. You have certain SLAs that are there to be met. This range, the speed can range anywhere between 50 mbps to 10 gigabits per second. So this is how it looks in terms of connecting your data center or your office to AWS. So there is something called a direct connect location, where AWS has their routers that are there in that location. Now, remember, this is not the AWS data center. Rather, it's another data center outside of AWS where they have kept their routers waiting for an interconnection from you. Let's say you also have co-located in the same data center and you have your own routers in that data center. You can essentially establish a connection between your data centers and that location. Then you further establish a connection between your router and the direct connect location. So as you can see here, the demarc location is the direct connection location. All right, that is the place where AWS has their own routers, which allows you to do a cross connect onto their network. You have to get something called an LOA in order to make that connection happen. But once you do that, you essentially have a private connection all the way from your data center or your premises directly into AWS. This is not going over the internet. You also have another option. Let's say you do not have the resources to actually run your own equipment within the direct connect location. What you can do is you can actually take the help of somebody known as a direct connection partner, right? This, let's say, somebody like Verizon, somebody like Sifi in India, somebody like Airtel, Tata Telecom, etc. They actually have their own equipment that is already located in the same data centers as the AWS routers. What you can do is you can request for a connection with the direct connect partner. So the connection between your premises and the direct connect partner will be taken care by the direct connect partner, right? Basically, whether it is something like Tata Telecom or Verizon, whichever it is, you will be paying for this much part. They will then make an interconnect into the AWS routers in the direct connect location, and you will get access directly like that. This actually lowers your cost, um, and it doesn't actually give you the headache of managing your own equipment there. You can connect through any one of the direct location partners. When we talk about redundancy in this, you can think of it like this, where you have two different direct connect locations. For example, in India, there are multiple direct connect locations. There are in Mumbai, Bangalore, etc. So you can actually do a direct connection through two different locations in order to get redundancy. Well, when you talk about redundancy, never stop at one or two. You can definitely go ahead and do multiple redundancy as well, which means now you can have four direct connect connections going through two different direct connect locations. All right. A little bit forward there. All right. So I intend to cover this in much more detail in the next webinar, guys. So hopefully I'll send out the dates and the timeframes later on. So VPN and direct connect. So what's in the next section, guys? It is basically about going from one VPC to multiple VPCs. So when we have 5, 10, 50, 100, 200, 300 VPCs, how do we start dealing with them? How do we do transit VPCs where you have all the traffic passing through a single VPCs, then connecting to all the other VPCs? We look at something called private links as well. Then obviously we'll go in depth into the hardware and software VPN setups. We'll look at something called VPN Cloud Hub. We look into more detail about Direct Connect itself, something called Direct Connect Gateway. Then we'll talk more about public WIFs and private WIFs and global public WIFs and all of that that comes along with the Direct Connect setup. All right. Now, I just want to quickly demonstrate this VPC peering, guys. If hopefully there's some time here. Okay, I want to show you VPC peering. So I'm going to create another VPC, and let's say I'm going to do a 10.0.0.16. Okay, so I have a new VPC there. Let me create a subnet for that. Okay, I have created two VPCs now. One is a 10.0.0.0 and one is a 10.1.0.0. Okay, so I'm going to connect both of these VPCs together and enable VPC peering. Okay, so let me first go ahead and launch an instance in the second VPC. Okay, I need to connect it to an internet gateway. I know we are past our scheduled time, guys. Just give me another 10 minutes and I'll try to wrap this up. So I'm just adding a new route on the new VPC route table, sending it to the internet gateway so that I can connect with that EC2 instance. Okay, so this is my first instance in my first VPC, and this is my second instance in my second VPC. So I need to get them both communicating with each other. At the moment, they won't be talking because they're in completely different VPCs. All right. So if I try to ping them, they're obviously not going to work. So from my first instance, if I go ping, other one, it's obviously not going to work, right? I haven't opened up the security group, but even if I did, it's not going to work right now. So what I'll do is I'll go to my VPC. Okay. I'll go to peering connections. I will create a peering connection. This is basically I'm connecting two VPCs together. I will give it a tag for test. There is always a requesting VPC and an accepting VPC. All right. It doesn't really matter. The difference here is that if you're actually trying to peer two VPCs across two different accounts, then this matters as to who's the requester and who's the acceptor. But right now both of these are in our account, so it doesn't really matter. So I will send the requester as webinar, and the other VPC is in my account. It is in the same region, and I will give the other name, and I will create the connection. It's as simple as that. That's it. You just select both the VPCs, and that's it. Now it shows that it's in pending acceptance. I just need to go to the acceptance tab and accept this. Okay, so I'll go to the VPC. Oops. Okay, under the peering connection, just select the peering and just do accept request. Accept it. That's it. So now my peering connection is established. However, that's definitely not the end of the story, because we have to configure our route tables now. So now let's go to route tables, and where is the route table of my new system? So this is the route table of my uh, second VPC, right? That is 10.1.0. Obviously, if I want to send traffic to my first VPC, I need to specify that IP range here. So that's 10.0.0.0/16. Where should I be sending it to, guys? Any idea? Any idea where I should be sending this traffic to? Okay, it's simple. I just need to send it to the peering connection. PCX, this one. I just need to send it to the peering connection, right? So it'll automatically send it to the peering connection. Save it. Now I need to do the same thing in the other side as well. So I'll go to the other side. I will edit it, and I will create a route for the other VPC, which is 10.1.0.0/16. Any request that goes to that IP range, send that to the peering connection. As simple as that. So I will save that. Saved it. So the peering connections are saved. Now I'll just go make sure that the security group is also working. I will edit this. I will add rule, all traffic from, okay. Obviously it's not going to show me because that security group is in a different VPC. It's not going to show me the security groups of the other VPC, right? So in this case, I will have to specify the IP address. Now I'm just going to quickly just change this to just ICMP, and I'm going to leave it to anywhere because I don't want to open up the whole thing. Be more specific. Let me delete that ICMP one. I will do add role. I will do all traffic and I will do custom IP. Okay, what is the IP address of my first instance? It is 10.0.1.228. So that's 10.0.1.28/32. Remember, I cannot just put in a single IP as such. I need to specify the CIDR notation. So that's why I'm putting it as /32, and I will save it. Okay, so let's try this now. There you go, guys. So it's actually pinging from one network to the other network using the peering connection. So this is system 10.0.1.228. It is pinging system 10.1.1.221. I hope that demonstrates the peering connection. Any questions there with regards to VPC peering, guys? All right, I'm going to delete these VPCs and I'm going to show you how you can do things via the command line interface. So let me delete all my VPCs first. Okay, I need to kill my systems first. No, it's a security group that is default denial, not the NACLs. NACLs is default allow both inbound and outbound. You saw the rule in the NACL, right? Which was the first rule was allow all, right? On both the inbound and outbound. So it's directly allow all. In the That is why we are changing the security group, because security group by default is deny all inbound, allow all outbound. That is why we had to open the port on the security group. Okay, I just want to quickly show you how to do the creation of the VPCs through the command line interface. So I'm just waiting for these instances to be terminated. Okay, so let me kill my VPCs. I actually should not have killed my first instance because I needed that. Okay, while it's deleting it, guys, I just want to quickly say that we do have another AWS Solutions Architect batch that is actually starting on Monday. So if anyone is actually interested in joining it, I think you guys already have the link. If you do not, you can just go to ecom.in/training and AWS Solutions Architect course. It's a 15-day course, guys, and it's myself that I'm taking it. We do have multiple batches. So depending on which batch is more full, we'll go ahead and do that batch, maybe 2 batches or so. It's a 15-day course, guys. There is actually a 35% discount on the total of 19K for those who are interested in doing the actual solutions architect course. It's starting this Monday, so if you'd like to join in, please do let me know before end of day today or tomorrow, so that I can get you registered on it. All right. Okay, so our VPCs are deleted. So now I'll show you how you can actually create them directly from the command line interface. All right, so let me log into this instance. Right. Let me just set up the zones. I'm just configuring the AWS command line interface. That's it. Okay. So I'm now ready to pass commands to directly work with regards to creating VPCs or all of this, right? So let me go to the VPC. So you can see there is nothing here except the default VPC, right? And the subnets are all of the default VPC. There's nothing that we created. Route tables, again, it's just the default route table for the VPC. Internet gateway is also deleted. All right. So rather than going through the buttons on the console, guys, you can always directly pass command lines in order to create anything on AWS, literally. So in order to create a VPC, it's pretty straightforward. AWS EC2 create VPC, and you specify the CIDR block. All right. So this is just one line of command. I hit enter. There you go. The VPC is created. I refresh this. There you go, my VPC. You see how quick it was, rather than going through all those and selecting different options and doing that and doing this. That's it. I just passed one line command for the CIDR range and it created the VPC. Now that I have the VPC ID, I can pass the remaining commands in order to create other things on the VPC. Right. So let me show you the other commands. Clear this. Now let's say I want to create a subnet, right? I specify this command which says create subnet. It says create subnet. I give the VPC ID and I give the CIDR block of the subnet. Okay. Before I do this, I'll show you that there is no current subnet right now. If I go to subnet, there is no subnet here other than the default ones for the other VPC. Okay. So I'll hit enter on that. There you go. It's created a subnet. There you go. 10.10.1.0/24. Let me show you the remaining run. Let me just copy over the VPC ID. There are, of course, additional parameters that you can specify. For example, here I just created the subnet without specifying the availability zone. If I want to, I just need to like do availability zone and I specify US hyphen east 1A and I change the CIDR block to 0. There you go. It's actually created one more in US East 1A. There you go, US East 1A, right? So you can specify additional parameters if you wish to. So let me create a route table as well for you. So again, route table creation, pretty simple. Create route table and pass the VPC ID. There you go, route table is created. Now if I go to route tables, I have a new route table that is created, which is not the main. The main route table is always there, but then I created an additional route table. Now, obviously, if I want to create an internet gateway as well, simple. I'll just pass the command to create the internet gateway. There you go, my internet gateway is created. Now I need to associate this internet gateway with my VPC that I have. That's also just one line of command. Is I attach internet gateway internet gateway ID, and VPC ID. There you go, it's attached. So if I now go to my internet gateway, as you can see, it's created the new internet gateway and it's already attached to my VPC as well. Now let's go ahead and create, let's go ahead and create an entry in the route table. All right, so let me go to route table. Let me copy the route table ID, which is this. Okay, so I clear that. So I'm creating a route entry inside the route table, which is the same thing as I mentioned for our internet gateway, which is 0.0.0.0/0, and it is going to the gateway ID. And is that my internet gateway? Let me check. That's not my internet gateway. If I pass this command, I'll just show you the existing route table. So under the existing route table, there is nothing there now except for the local route, right? So I will enter this. Okay, I can show here destination. A small error in the command. Done. Refresh. There you go. Done. It's added the new route. And as a final step, I will go ahead and attach the route table. I will attach a subnet to the route table, right? So I will take my subnet ID first. So I am associating my route table with my subnet, right? Pretty simple. So I'll mention the route table ID and I'll mention the subnet ID. Let me first show you that it is not associated right now. So if I go to my route tables, subnet associations, there is nothing associated as of now. All right. So I will pass that command. There you go. The association is done. Now if I go to route tables and refresh, as you can see, there is actually the route table association. So we did all of this by just passing 4 or 5 lines of command, right? So you can see how you can actually do this by, through the command line interface, where you can literally manage any service on AWS, especially with networking. It's much more easier through the command line than going through all of these buttons and clicking and adding certain boxes. You might miss some. Instead, you can just run a single command to get a lot of things done. Obviously, you can go more advanced and do things like cloud formation and all of that, which is a totally different thing. But if you do that, like at a single click of a button, you can get exactly your VPCs, your subnets, your route tables, your internet gateways, everything at one go, right? You don't need to spend a lot of time trying to manually create it. All right, guys, with that, we have come to the end of our current webinar session, guys. I'd like to thank you for listening in. And if you are currently watching this via the YouTube window, or if not, you can just click on the YouTube window and you can click on the subscribe button, so that if at all in the future there is new videos that are added, or new sessions, you can actually get notified of those sessions. So please do subscribe. Also, like I've mentioned, any of you who are interested in actually doing the full AWS Solutions Architect course, I'd be more than happy if you would actually go ahead and register, so that we have a batch starting on Monday. All right. Once again, I'd like to thank you for listening in. I will try adding that bit about the private connectivity once I fix the proxying on my putty correctly, so that it passes the key. I actually want to demonstrate it to you how to do the jump host, which is going from the public to the private using the private IP and then trying to reach out to S3. So I'll try to add that to the end of this video later on once I fix that. If not, I'll post it in another video as well. Once again, guys, thank you for listening in. And if you do have any questions before we end for the day, I'll give you another 4 to 5 minutes to clear out any doubts or questions that you have. I will be putting out notifications media as well as since you have already subscribed, guys, you will be part of the mailing list. So if at all there is any new sessions coming, you will get to know of the dates and everything. So no worries there. We currently don't have DevOps, but hopefully in the next month or two, we'll try doing that. Like I've mentioned, guys, I do have a company to run, so I cannot do trainings 24/7. So I'm just sticking to the solutions architect course as of now, because what you get from that is, see, we deal with a lot of clients on a daily basis, right? And we architect solutions for them. So what you get from those course, the course is actually that real-time scenarios where we look at those solutions and we talk about how you design those solutions, and what are the different scenarios that you would use for different applications or different environments, etc. Right? So as of now, I'm just sticking to the architect side of things. Hopefully in the future, next month or two, once things actually clear up a little bit, because we're dealing with a little bit a lot of things right now. So once that is done and I find more time, I might be able to do a session on DevOps. Suresh, I would recommend you hit the subscribe button. Once the video is up, you will get the direct notification of the link. It should be on the same YouTube channel. You can just come to the channel name. It's EICIT Learning. All right, guys. So it's touching close to 8 o'clock now. Sorry, we had to extend by another half an hour. Hopefully, in the future, for the next session, we'll cover a little bit more in depth on the VPN side and the Direct Connect side. Also, we'll discuss about having multiple VPCs, like I mentioned, things like transit VPCs, etc. I hope you found this session helpful and informative. I would really appreciate it if you could leave some feedback or comments once this video is up. And I'd like to hear back from you if you have any other comments, right, guys? If you have any other feedback, I'd love to hear it from you. The PPT won't be shared, but the video will be available, so you can take a look at it. All right, guys. Thank you, and you all have a good day, a wonderful night ahead, and for some of you, good morning for the rest of the day. Bye bye, guys. Thank you.